We are all part of the AgriFood ecosystem, and data drives our businesses along every step of the way. But when that data is recorded in disparate systems, it makes it difficult to work efficiently with buyers, auditors, and regulators. For example, sheep producers collect a wealth of data about the quality of their sheep, their farming practices, and their business. Many different participants in their value chain need this data to inform their own work. A producer needs to fill out forms every time they sell a sheep, sell their wool, and show their practices are ethical. Most of the information being requested by quality assurance and compliance programs is the same. For every form, a lot of the same data needs to be entered again, taking valuable time and focus away from operations and increasing the chance of mistakes. Do you feel like you are working harder than your data is? Imagine only entering data once and being able to send it wherever it needs to go. The Australian AgriFood Data Exchange aims to deliver an interconnected data highway for Australia's agri-food value chain, allowing secure, accurate and timely access to information along every step of the way. For producers, this means being able to choose what information to share, with who and for how long, without worrying about each individual form, leaving more time to focus on producing great products, adding value, and getting your data to do the work instead of you. For more information, head to ausagdx.com.au.
Well, good afternoon and good morning for that matter. We could almost stop there. The cartoon said it all. It was a great start to our session today. Good afternoon and good morning. As I said, I extend a very warm welcome to the 400 plus participants in this wonderful series of presentations that we're going to hear today. In doing so, I'm speaking from the Kulin Nation of the Wurundjeri people, and in the regards to them and other communities upon whose lands you may be joining us from, I want to acknowledge and pay our respect to all generations of the traditional owners, all of those people who have occupied these lands for more than 60,000 years. What I'd like to do, as well as welcome you, is just to make a few opening comments, if I could, explain a little bit about the agenda, not in any detail, but we have got a very solid program, and it's a fascinating one, I think, today. We begin with a moderated panel session. It's not too long, but it's a very important one. It's several of our industry leaders who will make comments about how an interconnected data highway for Australia's agri-food value chain, how it will transform their areas of responsibility, whether they're in industry, whether they're in government or whatever, wherever their roles are along that value chain in agriculture. After that moderated session, which is about 25 minutes, we will move into a series of presentations on the experiments that have been undertaken over recent months. We start with data for compliance and certification. That's for the sheep and wool sector. We go to biosecurity and contamination, information for grapes. We go to voluntary benchmarking for comparisons and decisions for grain producers. And we go to a compliance and traceability for rock lobster quota. We go to that experiment. So we've got 4 experiments. After each one, there will be an opportunity for audience participation, 10 minutes. So ready, and if you've got any questions or comments, have them ready. It won't be an extended period of time, but a very important one after every one of those sessions. I do think that the experiments have been remarkable in lots of ways. I mean, we set out to find out what was the best technology, what were the major lessons to learn from the technology, the different options that are out there. Each of these experiments involves a different technology provider, a different company. They've all got great strengths and we'll see that unfold this afternoon. But one surprise thing that surprised us, I think, was that the experiments proved to introduce to a lot of people in the industries themselves the value adds, the opportunities, the outcomes that can be realised when you manage data in this sort of way, when you exchange data, when you get data into a form which can be exchanged across the value chain. People saw things open up that they hadn't realised were there and were there for an opportunity. So it's a great session today, I think, and I'm looking forward to it immensely, because we haven't had a report out of the experiments for a couple of months now. So now that they bring it all together, it'll be fascinating. The motivation, of course, for this data exchange project stems from the absence of any single easy-to-use platform in Australia which would allow primary producers from across the agricultural industries and other value chain participants up and down the supply chain to exchange their data efficiently on agreed terms with trusted service providers or other interested parties such as government and researchers. Now, that problem, that absence, as a result, it means that we're unable to access and take full advantage of the huge amounts of data that they are generating. And we're seeing it in many other industries that are well ahead of us in Australia in this regard. And, the current disparate, siloed and proprietary data systems, which characterises so much of agriculture, not just on properties, but up and down the supply chain, they lead to costly inefficiencies. They lead to poor collaboration. They lead to wasteful use of critical managerial time, and they lead to a loss of opportunities for the sector. So if we do move and get this agri-food data exchange in good shape and in place and functioning as it should, we'll end up with a system designed and controlled by the agri-food industry itself, and we'll have the opportunity to share data, to reuse data, to merge data from disparate systems in a secure environment. So this is not about creating some big repository of data. It is about creating an exchange which enables the movement of data, and it's all done on a permission basis. When you saw it from the cartoon, when someone can push a button and not have to enter more data that they already have entered some days before or weeks before, when they can enter it and use it several times over for different purposes, all of a sudden the efficiency, the time efficiency and all the rest is very meaningful. And if we do get this agri-food data exchange designed and controlled by the industry, in doing so, we will stimulate entrepreneurship, we'll stimulate consumer trust, and we'll stimulate innovation. And consumer trust in particular is fundamental. In fact, the trust across the system, we have got systems in different parts of the industry and they're not being used as they should because of the lack of trust. So this system is designed to build trust, and critically it will enable us, I think, also to catch up with some of our major competitors. At the moment, some of our major competitors are already benefiting from such a system, and we've fallen behind. And it's meaning that the very important, advantages of such a system, as you saw with that cartoon at the start, for that matter, the ability for traceability data systems. It's available to other countries, but not to us in the way in which we could and should be using it. The need to unlock more management capacity, the need to ensure verification assurance, the need to improve access to capital, the need to provide digitised compliance outcomes, the need to enable data owners to share access to data with RDCs, for instance, with researchers and with entrepreneurs on a permissioned basis, and to make it easy for data owners to share useful data with biosecurity agencies. A number of these outcomes, we're going to see today how it can be achieved, and achieved very effectively, and deliver spectacular outcomes for our industry. But I just conclude with a comment that, for my part, and I've been in and around data now for the best part of 30 years, and ran and built my own data company 20 years ago, doing these sorts of things in another part of the Australian economy. But for my part, I see this AgriFood data exchange as truly transformative. It will lead to a revolution along the entire agricultural supply chain. It'll prompt and enable thousands of innovative investments. I exaggerate not. It will enable and prompt thousands of innovative investments if we can get data standards and data sets and data into a form that is then able to properly use a data exchange that's being built. We will see a revolution from the farm to overseas points of sale. And in a way, in a sense, to me, it's a nation-building project of great moment for our sector. And I hope you can all capture that vision as it unfolds during today. Thanks very much.
Thanks, Andrew. That's fantastic. Thank you for that. Those great words of introduction to today's session, and it's a real pleasure for us to have your leadership as the Independent Steering Committee Chairman on this program of work. And that's no small order. We have 38 organisations that have come together to support the endeavours that Andrew has just introduced. You'll see those organisations represented on the slide we have up at the moment. And I'd just like to echo a couple of key points Andrew makes, that it's about enabling infrastructure that supports the connection and the enablement of data to be moved between stakeholders. If we do that, then there's wonderful opportunities. I think Andrew used the language, thousands of innovative investments, wonderful opportunities for technology providers, ag tech vendors, organisations to create applications that can benefit from accessing those data sources. And if we can do all that, we will truly be a long way forward with creating that interconnected data highway for Australia's agri-food value chain, which of course is the vision, always making sure that the owner of the data permissions the release of the data. If we move forward one slide, please. One thing that you're going to hear later on today is an overview of the experiments as Andrew's introduced. What I'd just like you all to be aware of is how special the collaboration framework is in this project, and you'll soon see that when we get to the moderated panel conversation. But as you can see here, there are non-traditional partners working together, problem solving, bringing their knowledge of what's worked in parallel industries for the benefit of others. If we take by way of example the lobster industry, which we'll hear about today, it's fairly unusual to have Eggs Australia and Australia Wool Innovation working on a project that relates to traceability and digitisation of quota for lobsters. But that's what's happened through this program of work. So I'm really looking forward to continuing that knowledge sharing through the course of today. My name is Ben Van Delden. I'm one of the partners supporting the program of work from the PMO perspective, and it's my great honour now to moderate a panel with some of the leaders across the project sponsoring organisations. So joining me today by phone is Christine Mulhern, Assistant Secretary of Innovation and Consumers at the Federal Department of Agriculture, Water and Environment. So welcome, Christine. It's great to have you online with us. Also, we have Dr. Patrick Hone. Patrick is the Managing Director of Fisheries RDC, looks after the research and development of fisheries and aquaculture activity in Australia. Welcome, Patrick. Also joining Patrick and Christine is Dr. Jane Weatherly, the Chief Executive Officer of Integrity Systems Company, part of MLA, that is the lead contracting organisation that's bringing this project to Australia. So welcome, Jane. It's great to have you on for this session. And lastly, Dr. Ryan McAllister, Mission Leader for the Trusted AgriFood Exports Focus that CSIRO, our National Science Agency, is driving. So it's great to have you all on board for this conversation. Over the next few moments, I'd like to just get inside the minds of these leaders and really understand from them what the future looks like. If you imagine 2024, where the Australian AgriFood Data Exchange actually exists and is in operation, we're going to just hear from each of these leaders on the transformation of their organisation and the impact that it's had on the industries that they work with. So with that in mind, Christine, if I can start with you with the first question of why is it important for DOR to be part of the AusAg Data Exchange initiative?
Thanks, Ben. It's a pleasure to be with everyone today. The department, like Australian agriculture more broadly, is facing big, complex challenges and opportunities. It's not just the natural disasters we've faced recently, but also the challenges of global markets, increasing international competition, climate and water-related risk, and global economic shocks, such as the COVID-19 pandemic. Let me be clear, Australia's an exporter. We sell the majority of our goods overseas, and we want to maintain market access in a changing trade environment. The sustainability credentials are increasingly important to our existing and potential domestic and overseas markets, like a whole bunch of other credentials. We want to get the most value for our product, which means high-value products to premium markets. So let me just switch a little bit then and talk very briefly about pineapple. When I look at my local Woolies catalogue today, it's $2.90 for a pineapple. They're grown in predominantly the north of Australia, and we grow the same varietals and same types of pineapples we've grown since about the Second World War. The pricing hasn't changed that much either. The value that a pineapple farmer in North Queensland or the Northern Territory gets their pineapple is about $1 Australian. We don't export, we don't really import, it's just a static kind of market. And when I talk to the retailers, they tell me that they don't sell a huge amount of pineapples, which is odd for a pretty summer-loving country. But what they do know is that a nice big display of pineapples at the front of their store generates about an 8 to 12% bump in what they call summer sales. So think juices, ice creams, that sort of thing. If I work and live in Costa Rica, I grow pink pineapples, and I mean bright pink. Think of the highlighter kind of pink. And they are GMO modified, and they kind of miss that enzyme that sometimes when you eat a pineapple, you get that fairy taste in your tongue. And they sell for about somewhere between $40 to $50 US per pineapple, which is a bit different to the $2.90 Australian that we sell ours for. And there's about a 3-year wait list to get one of those pineapples. I'm personally on the wait list, so we will one day as a country be an importer of pineapples because I'm getting myself one of those pink ones. But think about what that means. If we want to look at how to get the highest value products to those premium markets, we want to prove it. Pineapples and doing things differently and being able to show that we're changing as our consumers and others change with us is really, really important. So how do we show that we're selling that premium product, which isn't always as obvious as the bright pink on the inside of a pineapple when I open it up? Because let me be clear, with these pineapples, they look the same on the outside, you just slice them in the middle and they're obviously very different. Well, this is where data is important. Being able to share data across a system and with our trading partners and to prove that this is a premium Australian product is incredibly important. It's a way for us to all work together to demonstrate just how good our products are, from the farmers through the processors through to the consumers. There are a plethora of other benefits as well, such as reducing waste, knowing how long a product spends in a location, environmental conditions they're subject along the value chain, allow decisions to be made, which will increase our efficiency and reduce wastage. We can manage biosecurity risk. We can make it easier for everyone in the system to trace movements of animals, plants and equipment, which will help us prevent and manage biosecurity concerns. And we can just see the provenance of what we are doing. So for the department, these are all really important things that we think the data exchange can help with.
Thanks, Christine. That's great insights, and working alongside industry to bring that data together is obviously how we add even more value to that regulatory data as well. I might now ask Patrick Hone your perspectives, please, on where you see your organisation working differently now that the Australian AgriFood Data Exchange is operational.
Thanks, Ben. And today I'm on Ngunnawal land. I'm meeting here in Canberra. It's just a pleasure to be here. And just a couple of comments. First of all, I'd just like to thank my fellow partners to be involved in such an amazing achievement with what we're talking about today. And I think, the first thing is, why is FADC involved? Well, the first thing is that the opportunity that we've got in front of, that's been very well described already this morning, is much larger than the FADC, the fishing and aquaculture, can achieve by itself. So that's, the actual, what we're trying to achieve here is very large. To actually create an enabling piece of infrastructure that will allow us to do this data exchange will require a significant amount of work. And we quickly realized that in our systems, that we could fall the old mistake, which is taking basically the old analog and paper systems and just turn them into digital systems, just make them digital. But that would never work. That would never create a true digital connectivity. We also know that if we don't break down some of the ways we look at data in terms of how it gets siloed in different systems, again, we wouldn't be able to get the value add. We also realise that when we look at the opportunity in front of us, that for fishing and aquaculture, we are only just one part of a regional community. And Ben, when every time you ask me a question today, I'm going to remind you, well, fishing and aquaculture might be in the wet bit and you're on the dry bit. We are part of regional Australia, and the part of regional Australia, whether it's the community of Geraldton or the community of or up at Lismore right now with the floods, we're all part of regional communities, and what we need to do is work in regional communities at a national scale to make things happen. And so this data exchange for us is a lay down misère. It's quite obvious we need it, but we can't do it alone, and that's why FADC is involved with so many partners.
Thanks, Patrick. That's really good insight, and I know you'll be looking forward to the lobster use case that's coming up at the back end of today. Might just pass across to Jane from ISC. Jane, in the context of MLA and ISC, how do you see your organisation working differently with this kind of infrastructure that's available?
Yeah, thanks, Ben. And I'm on the Central Tablelands, New South Wales, which is Wiradjuri country. Look, there's just so many, benefits that we'll be seeing from it. And essentially, we're a data company. So AusAg Data Exchange is offering us a complete solution for helping really address many of the pain points we have around our data management and really maximising the benefits that we have and can deliver industry with our data. Internally, we've really focused on our ways of working as a company over the last 12 months. And so we've done a massive assessment and developed up an enterprise-wide data strategy, which enables the establishment of a common service-led roadmap, which means that all data-related activities across ISC are complementary and coordinated across ISC. Our total approach to data management now, data reporting, the feedback flows that we've got all feed into our strategic business decision making. And beyond that, we've got our own MLA data platform as well, which has been developed to, really pull together all the different data sets that we have at our fingertips, such as the National Livestock Identification database, which is our industry's traceability system, our LPA, Livestock Production Assurance Program data, our National Vendor Declaration data, to see how we can make it all interoperable and really enhance our program insights and delivery through that process. Beyond that, we've got data on carcass feedback data, animal health data, genetics data that we're also wanting to try and see how we can make it all interoperable to generate insights that industry's never had before, that we can help to really drive supply chain performance. So obviously we're extremely focused on really getting organised around the data that we have and really wanting to direct that so that we can get the most benefit we can for industry.
Thanks, Jane. That's great to hear. And I think now, Ryan, you always have a slightly different lens on on most things, but particularly this project, which is what makes it really valuable having you on the advisory council. And some in the audience, Ryan, might think, it's a bit unusual for CSIRO to be working in this project as an investor and a shaper of it. They might have otherwise expected CSIRO to be in the technology solution role. It would be really helpful, I think, Ryan, if you could just give us some perspectives on why it's important for CSIRO to be so actively involved in financially supporting the project at this point.
Great. Excuse me. Thanks, Ben. And Yaga and Turrbal for me, which is up in Brisbane. I could almost say, so Jane just said that ISC is a data company, and I could quite simply say that CSIRO is an impact company. And I could leave it at that, but I'm going to flesh it out for about 3 minutes. So what I'm going to try and do is line up some of the objectives of the data exchange with some of CSIRO's mission work that we're doing at the moment. And essentially our missions program is about really sharpening our organisation's focus on impact and quite narrowly defining places and impacts where we can build partnerships and go hard and fast, so like on a 3 sort of 5 year time scale. So I lead something called the Trusted AgriFood Exports Mission. This is about growing the value that we capture from exporting agricultural products. So it's improving market access, automating compliance, building trust in credentials. And it's worth saying, in case I forget another points, it's a partnership, and it's actually with the Department of Agriculture and MLA as our core partners, and a lot of other partnerships in projects and so forth. Now, we're about impact. We're about the outcome. We're not actually about the method. So we never presume that we're about digitisation. But in this space, even though we come at it from an impact point of view, it's pretty clear that digitisation is at least part of many of the solution to many of the problems that we face. So really in this context, what we want to achieve in the missions program, and specifically in Trusted AgriFood Exports, has got really strong alignment with the Australian Agri-Food Data Exchange. And I want to make a few more points. So one for me is that there's already many digital platforms out there in the ecosystem. Some of these, or many of these, already at least integrate data quite effectively. Quite a few of these have got decades of paying customers, so they're quite mature, and there's a range of other companies coming through with new technologies. And firstly, to say, we all think that's great. That's a really important part of what underpins what we're trying to achieve. So they're there, but there's 2 ways that have kind of been touched on already around how agriculture as a sector, but also how these digital platforms can actually do quite a lot more for the system. So this is the crux. If we can build a digital infrastructure that can do the grunt work for facilitating data exchange of common value across multiple applications and commodities, and actually better still, if we can use this exchange to facilitate the sharing of information and analytics of information that couldn't be shared in its raw form. So if we could do those 2 things, we would achieve 2 really important things. So one is that the existing applications will generate better value because they'll be able to leverage information which they didn't collect through an exchange. And for me, I'm an economist. One thing that's really important is if we do this, we can actually share the cost of collection and creation of data across these multiple applications. And this changes the economic fundamentals. And a lot of people say, farmers or supply chain actors need to be convinced to use digital tools. My perspective is it's not so much that they lack information, it's actually that the value proposition isn't really there. So they need some underpinning infrastructure that can actually change that economic proposition. So absolutely true, the data exchange will need some foundational or consumer-facing services to kick things off. These can be delivered through the experiments that you hear about today, and in other ways, some could be delivered through some existing platforms as well. But clearly here, the big play is about what sits below the applications and the experiments. So this is developing the common underpinning digital infrastructure that can work across applications. It's risky, obviously. It's not so much technically risky. Rob said he 20 years ago ran a digital company. I come from a digital background before my PhD, so 30 years ago. Technically, it's no problem, but it's about getting the model right and actually getting some of the social sciences right. So we're on the inside because we've actually got a vested interest in this platform being set up as a potential end user when we're trying to solve problems for the Trusted AgriFood Exports mission. But the big one, and I'm a mission, but CSIRO is much bigger than me, this is really potentially incredibly profound in terms of the impact it can achieve. And quite simply, if it's got profound impact and CSIRO believe that there's something that we can contribute to, then it's something that the Trusted Ag Food Exports Mission and the National Science Agency just have to be a part of to play our role and contribute. So that's the crux. Thank you.
Thanks, Ryan. That's really good insight. Great perspective, and like your linkages to unlocking value for so many stakeholders through that core infrastructure. Patrick, if I can come back to you and ask you how you think beyond Fisheries RDC as an organisation, and I know you touched on regions earlier, but how do you think the wider industry is going to benefit from this kind of infrastructure? You know, whether it's producers, transporters, processors, exporters. What does your mind's eye sort of tell you about what the future looks like with this kind of solution available to people?
First of all, Ben, great answers from Jane and Ryan, amazing. I'm going to buy in again. Look, I think it's the first thing I'd say, and I think Ryan touched on it, we really do not actually know all the things we're going to get out of the data exchange right now. You know, we can only sort of secondly guess. It's a bit like saying when someone developed the internet many years ago that we'd suddenly discover all these amazing things that would come. So it's very hard to be the crystal ball. But what I can say, I'd like to use just a little example. So in the lovely Bega Valley, there's a group looking to develop the circular economy. And they're trying to ask the question, how can you change the way we do ag, fish, forestry, land use, everything, in a way that means we're more competitive in the future. We can bring in completely different thinking about how we use our energy resources, inputs, outputs, everything. So when you think about that, that's going to require a completely different way of doing business and connectivity. That means dairy and fishery will have to connect. That means rivers and land will have to connect. That means the users, local councils, waste, everyone will need to connect. Now, to make that happen, we're going to need an enabling infrastructure to make that happen, you know, in terms of that data exchange. If you take the Bega Valley and you put that in any one of our communities around the country, whether that's Cairns or Geraldton, Port Lincoln, there are many microcosms where local people are already talking about energy hubs. We're going to share energy and transfer energy. But then how do you share the data that goes behind it? So there's lots of things. We're already seeing supply chains being completely reconfigured because of what happened in the pandemic. So to me, it's very hard to understand all the opportunities right now. I don't have a crystal ball. But I think one of the things I realize for my sector, which is fishing and aquaculture, the opportunity of working with Meat and Livestock Australia, with the cotton guys, with the wine guys, with so many people, with so many smart ideas. And if we can share those smart ideas and translate this into this infrastructure, my sector is going to be so much better off. But more importantly, the regional community that they're embedded in is going to be better off. And to come back to Andrew Rob's original premise, if we are going to compete in a future world, doing things slightly better won't work. We will have to do things very differently if we are going to compete in future economies. And for us, that means this data exchange is like one of the critical pieces of infrastructure that's going to actually secure our future for the next 50 years.
Wow, that's inspiring. I buy into that as well. I think it's really interesting to hear how you make those connections between agriculture industries coming together as well, Patrick, because a lot of effort goes into connecting within a supply chain. But you know, you're really starting to widen the remit there to get people to think about how they can work across sectors as well. And hopefully this afternoon, when we see the experiments being played back, we can see the extendability of some of those from lobsters into other markets as well. So thank you, Patrick. Jane, wouldn't mind just asking you the same question. Beyond MLA, the organisation, when you sort of look at the broader red meat sector, how do you imagine the sector being impacted by this kind of available technology?
Yeah, Ben, look, I think it's been touched on already in terms of the void that I think AusAg Data Exchange is filling, that it's addressing a pain point of all industries around the need for a trusted data technology infrastructure with really strong governance structures and really safe ways of sharing data. on the data owner's terms. So all sectors across our supply chain are very focused on data. They all collect a lot of data, which they build and store and analyse for their own purposes. Imagine the type of analytics that we could develop if every stage of the supply chain could have their data to enable to talk to other data sets in real time on their own terms to really drive efficiencies in their engagement and really enhance their own business performance and those of their suppliers. So the benefits are endless, I would think, from joining data sets, which Patrick really said really well. To generate from our perspective, really front of mind at the moment for our supply chains is how do we generate the data around verified practices to underpin trade negotiations, for example, around animal welfare and sustainability. Other really areas of focus at the moment is real-time data recovery, disaster recovery, and systems where industry and government can interact and engage really efficiently when the country is going through natural disasters, which we are at the moment. So a lot of that response is all based on data systems and being able to see it in real time. So there's a lot of work still to be done, I think, with regards to the governance elements and building trust and making data interoperable, and really making it secure is obviously paramount. But I think that the point is that it's been proven around the world that it's possible that data exchanges are in existence in other countries and found to be really effective. So for us, Australia, the time's right for us to really take it to a whole new level.
Nice one, Jane, and thanks for answering Andrew Doherty's question in the chat as well around where is this happening elsewhere. So certainly the UK, Netherlands, Germany, the US, markets like that as well. So last comment for each of you, and just a quick one because we're just running short on time, but final remark, what are you personally really looking forward to seeing this afternoon from the demonstrations? Maybe Jane, if I start with you and then go to Christine.
Oh, look, Ben, I ultimately, I'm pretty old and conservative with regards to what I think is actually possible. So I'd like to really see that my conservatism around what's possible to be really turned on its head. I think everyone is going to be blown away. So really looking forward to it.
Fantastic. That's a great challenge. Christine, your thoughts? What are you looking forward to?
In some ways similar to Jane, in some ways a little bit different. So as someone from government, I want to be made a little bit uncomfortable. Government is about being comfortable. We're regulators. We're looking to, to understand how things fit together. I want someone to push me. I want someone to make me feel a little bit uncomfortable and go, oh, how far will that push me as government? How far will that push me as a regulator? Can I actually, really meet that requirement? I'd like to be a little bit uncomfortable out of today, Ben.
Very good. Well, you got budget coming as well, so that might continue with that theme of comfort or uncomfort. Good luck for both. Patrick, what would you like to see from today?
It's a bit of a wish list, Ben. So first of all, I've had this long-term view that a little bit like the internet deregulated knowledge and information that made it available to everyone. We socialized knowledge. I'm hoping that we can deregulate data. But we need to deregulate data in a way that socializes but protects ownership. And, Jane made that very clear. We're not about taking people's data. We want to socialize data. And we need to really make it more available. So, what's my goal at the end of the day? I just want to see us buy into this enabling thing called the AgriFood Data Exchange. And I hope we can see that it's not just about lobster or grain or red meat. It's about rural communities working together more effectively. And probably we don't even know the jobs of the future that this data exchange is going to deliver. It's just quite amazing, the things that we're going to see, from natural capital accounting to all the new things that are going to come along from this data exchange. We haven't seen even the beginning of the tip of that iceberg. So, I'm very excited today, Ben, and I think our experiment on traceability is the must-watch one, so you're all going to stick around to the end. I'm sure. And just a big shout out to the team. I know they've been challenged, Ben. I think all of the teams have been challenged. But it's so exciting to see the amazing energy that each of these teams has brought to these experiments. And I think anybody who sticks around today and listens to everything is going to just be almost in raptures to hear just how clever we are in Australia. And, it's just another good example of how we work well together. Thanks, Ben.
Fantastic. Thanks, Patrick. And Ryan, what are you really looking forward to getting out of today, mate?
Well, I reckon I'm a risk taker, but actually my one for today is very, very safe. Actually, I'm just really keen to learn about what are the common themes that, the common problems that are coming across the 4 experiments. I want to, start thinking about how to solve those, and if we could solve those common problems, then, what opportunities would that unlock?
Fantastic. Well, thank you, panel, for sharing your views on the future and why you're involved. And it's I'd really like to say thank you for your time today, but also thank you for the amazing leadership you're showing on this project. And with that, Andy, rather belatedly, I will pass across to Andy Sholem, KPMG partner, who's facilitating today's session. And in your hands, Andy.
Thank you very much, Ben, and good afternoon, everybody. Look, I won't say much now, just to say that with these demos that we're now about to get into, they'll run in 3 parts. We've got a workstream chair who will introduce the demo in each particular case. We'll then go through the actual demonstration itself, and then the workstream chair will moderate a conversation where you will get the opportunity to introduce questions, and the presenters can take you through, and the workstream chair will moderate that conversation. We've got an hour for each of these demos to go through that cycle, following which we will have a short break to run a Mentimeter session with you. So you're going to need to have your mobile phones handy in about an hour's time to run that Mentimeter session, and we'll get you to contribute to a series of questions, some of which are free text, to get your ideas on those demos as we go. And my primary role today to keep things flowing is really to keep us to time. So if we can do that, we'll wind up getting through each of the demos, giving everything a really robust go, having a bit of a break in the middle to get a cup of tea, and then seeing the session out to finish at 6:30 this evening. So without any further ado, we'll move into the first demonstration of the day, and the workstream chair, who is the group manager from ISC Strategy and Planning, who will be leading us through that and introducing it, is Irene Sabota. And over to you, Irene.
Thank you very much, Andy, and good afternoon, everyone. I've had the pleasure of chairing the compliance and certification experiment over the past few months, and it's been quite a journey we've been on. Let me just put the slide in place here. Look, the experiment is really there to address the cumulative burden of compliance for producers through the processes in the sheep sector in Victoria and New South Wales. And it covers both meat and wool. And the experiments really started out with a pain point that there's currently a range of compliance and auditing programs that place reporting requirements on producers in the sheep sector. Often these producers, they're required to actually manually enter the same information on their operations and production output in several separate systems for a number of different compliance programs. And as a result of that, there are really concerns that are about the accuracy and quality of the data being manually entered, but there's also concerns around the time burden and efficiency of having to enter the same information multiple times. So the purpose of the experiment has been to see if we can build a solution, a platform or a service that can enable producers to collect data for compliance purposes and share that data, of course, with explicit permissions set by the producer with the relevant compliance programs in the required format. Some of the key success criteria we've been aiming for is, of course, reduce time spent by the farmer to enter the data. We're looking for increased accuracy and compliance with different quality assurance systems. Some new ideas to benefit stakeholders along the supply chains. And of course, see if we can increase the efficiency of auditing through more accurate and complete data sets. Now, we've collated data from a number of supply chain partners, and there's just a few I just want to call out. A special thanks to a couple of producer organisations that's been putting in a lot of work to collect the data, and that's Paraway's Barton Station in Western Victoria, Europambala in Baltra, New South Wales, McBride's Telopea Downs in Victoria, and Rich Haven in Central West New South Wales. And then, of course, also thanks to Australian Wool Exchange and Australian Wool Innovation and the Integrity Systems Company for sharing the data we've all collected on producers' integrity systems. But of course, there's been a broader working group sitting behind everything we've been doing. And as you can see, there's a number of different organisations that supported the experiment. MLA, the Australian Wool Exchange, and AWI absolutely has taken the lead, because we are right in the middle of this space around compliance. But also Charles Sturt University, Agriculture Victoria, Department of Primary Industries Regional Development in WA, the Australian Packaging Covenant Organisation, FIAL, the Australian Government, and the Department of Primary Industries in New South Wales, and of course Elders, and that's along with those producer organisations I mentioned just before. So a really strong group of support around our experiment. I'd like to now hand over to Andrew Cook and Andrew Skinner, that on behalf of Research Systems is going to take us through the solutions that's been provided. Thank you very much. Over to you, Andrew.
And in fact, Andrew Skinner is going to kick off. So Andrew Skinner.
Yeah. Thanks, Andrew. Well, look, thank you, Irene, and good afternoon, everybody. It's so great to see so many people interested in the work that we've been doing. The Research team, we're really excited to share the work that we've been doing with you all today. So same as Irene, just push the slide forward. There we go. So at the start of the compliance and certification experiment, we designed an approach that allowed us to co-design the project through some early workshops that we conducted with the wider project working group. Together, we explored the current state of the compliance and certification programs, and we identified initial pain points that may be addressed with a permission data exchange mechanism and appropriate data specifications. Now, with those pain points in mind and opportunities in mind, we examined the example evidence that was supplied by the experiment's industry partners. And it was secured through the MLA data platform that Jane Weatherly mentioned at the top of the call. And we began to test our assumptions and conducting industry interviews. And from this, we were able to start to develop the solution design for our prototype and collate the supporting business benefits that demonstrated the value of the data exchange for compliance and certification. So this work's culminated in the development of our prototype that we're going to demonstrate to you today. And Andrew and I are going to be taking turns to just walk you through that. So using our findings from the group workshops, we started the project with the following hypothesis: that data exchange platform may enable time savings for producers, auditors, and program administrators, that by reducing the overhead of participation for producers, a data exchange may increase program participation. And finally, that clear mechanisms for a data exchange could potentially increase producer trust and collaboration. To make the most of our interviews, we approached them against a defined methodology. This methodology, shown here, enabled us to test our hypothesis, consider how we would measure each benefit, and to develop our learnings, and specifically consider how we might scale the benefits identified through our interviews regionally, nationally, and across the supply chain. So talking to supply chains, we thought that for those of you on the call today not familiar with the red meat and wool supply chains, we'd quickly put up this slide because we refer to supply chain, the red meat and wool supply chains throughout the presentation. So this diagram illustrates the red meat supply chain from breeding enterprises all the way through to the retailer. And the wool supply chain is similar. However, slaughter and processing is replaced by wool processing, and also the wool broker plays an important role. As I mentioned earlier, we've been speaking to organisations across the sheep and beef supply chains throughout the project to identify the benefits for the data exchange. And we've been able to speak to producers, program administrators, consultants and advisors, auditors, processors, and even retailers. And we've put a couple of the examples of who we've spoken to on the slide, but again, Irene's already highlighted a number of those. We've also contacted and spoken to international organisations such as Red Tractor in the UK, who've already developed data exchange mechanisms for compliance and certification to try and learn some of the lessons that they learned. And everybody has been really generous with their time. In addition to the supply chain input, we also made sure that we had conversations with researchers, software producers and government to make sure that we understood how data exchange for compliance and certification evidence could also provide benefit to them. And one thing that stood out to us was that while there were many questions, everyone we spoke to could see value in a permissioned data exchange platform. And this was really encouraging. So we've only recently concluded our interviews. And as a result of our conversations and also the desktop research that we undertook, we've been able to identify around about 20 benefits along with potential realization mechanisms and the measurements around how we're going to measure the benefit of each. In many cases, we've also been able to use past industry research to quantify the potential benefit, and we'll be including this detail in the experiment final report. And as we go through our demonstration today, we're going to take time to reflect on those potential benefits. And with that, I'm going to hand over to Andrew now to present our platform solution.
Brilliant. Thank you, Andrew. Thank you, everybody. It's good to be with you today. I am calling in from New Zealand, where I'm on Tainui people's lands. I'm going to lead you through the demo, and Andrew and I will do a bit of a tag team around, you've just seen this piece, what are the benefits? Our solution here is going to demonstrate these key things that are on the slide. So firstly, how compliance requirements between the various schemes could be aligned to support the reuse of evidence that producers collect. We're not suggesting a wholesale merger of lots of different compliance schemes. The compliance schemes still need to be able to retain their own individual benefits and their own integrity, but we're suggesting that compliance requirements could be aligned to make it easier for producers to reuse their evidence. We're going to show how farmers can capture a wide variety of compliance data digitally and capture it through the season so that it can be used when audits come around. Importantly for the Australian Ag Data Exchange, we're going to demonstrate how a data exchange or integration platform supports the transfer of data between the farmer tools and other systems involved in the sector. And while we do that, we're going to show how farmers can retain control of their data and permission it for specific uses. Finally, we're going to show how data could be leveraged to show richer analysis and compliance than could be achieved with particularly traditional paper-based systems. I'm going to talk a little bit about the technology architecture before I actually try and show you any application screens. And that's important because otherwise you're never quite sure what you're looking at. And in the diagram that's on the slide in front of you, you can see a thick orange line which represents data exchange technologies. So this could be an Australian Ag Data Exchange, it could be an exchange of exchanges, just integration technologies generally, I guess. And you can see a range of the applications and systems that already exist out there in the industry. These don't have to be recreated anew. So you can see that there's farm technologies there. So that might include farm software, it might include data-enabled tools and equipment. It might include equipment of things devices. Industry systems could include government databases. It could include industry databases. And certainly in the scope of our experiment, the Meat and Livestock Australia MyMLA systems and solutions would fall into the industry systems space. And then you can see compliance tools and assurance schemes. And those are the tools that producers might use to show their evidence of compliance, and that auditors might use to carry out audits, and that compliance scheme operators might use to review compliance. And finally, you can see that there are supply chain partners because, as we've already talked about, data could be used, yes, on farm, absolutely, but it's also extra valuable when you can see it right along the supply chain. So all of those systems or solutions or applications you can see are connected via data exchange technologies, and that's what we're going to illustrate today. There's a couple of key components that we are going to show, and the first of those is called pure farming. So pure farming belongs to, it's a software platform that belongs to Map of Agriculture Group, to which Resair Systems belongs. It is an example of a data exchange technology. Technically, it's called an integration platform as a service, so IPaaS, if you like acronyms, and it is designed to connect together tools, solutions, and systems in the agricultural sector, and that's what it's been doing in overseas areas. As you can see from the little, probably too small diagram on the right-hand side, it's designed to ingest or take in data from a wide variety of different sources. Now, that may include applications that are aware of a data exchange, but it may also include traditional or legacy applications that have got no awareness and simply handle files. It may be rich data from remote sensing devices, or very, very thin data coming over networks from Internet of Things technologies. Key elements are that it standardizes and cleanses the data and aligns it with specific common data schemas or data specifications. And we think that that's a key element of any data exchange, is the ability to define shared open specifications that can be reused. Then it also is key is permissioning that data and giving producers control of their data and where their data is used. Applications can connect to the data exchange through APIs or data feeds, and of course we tend to think of applications, but actually as you move into providing advice or down the supply chain, often it's people and organizations who want to consume that data. And data can be stored in the data platform, and that's the standard pure farming model. So it's a sort of least privileged storage where you can't access the data unless it's being permissioned to you. But it can also be brokered through, in which case a data source makes data available. It can only be consumed by using the permissions that the data exchange makes available. So that's one component. The other component that we're going to see is a tool, a software tool called AgAssure. And AgAssure is an evidence portal. It allows producers to upload digital evidence for use in digital and hybrid farm audits. Andrew talked earlier about the retractor scheme in the United Kingdom, and that uses this same platform with different branding for providing assurance to thousands of producers. And we'll show you how a whole variety of evidence can be represented in that tool. So I'm going to switch across to my own computer, and we'll see if the magic of screen sharing will work, and get underway with that. And I'm not exactly sure which screen it's going to share, so this will be fun. Andrew, as I can hear you, can you see which screen has been shared?
Yeah, you can see the presentation slides.
Fantastic. That's what we want to see. Right, so you've seen this diagram before, and what I want to show you is some of the flows of data that might be possible through a data exchange. And for some of you, this is going to be obvious, but for others, hopefully it'll help you understand how data can be flowing from one party or one system to another. So my first example is the kind of obvious one, which is data being used from on-farm software systems and being used as compliance evidence in your compliance or assurance tools. But data could also flow from industry platforms and be used in compliance tools. And we're going to at least talk about and show you a little bit of the sort of data that could flow from Meat and Livestock Australia's NLIS and ENVD solutions into compliance tools. And then, of course, information from assurance schemes might flow through to supply chain partners, and that might include the obvious things like is this farm, is this property a member of this assurance scheme? When were they last audited? Were there any significant non-compliances? The sorts of things that a processor might need to know at the time of receiving livestock or purchasing wool. And then, of course, data might flow through from farm technology for use by the supply chain partner, and that might provide additional evidence that helps with product assurance or market positioning of that product. And we'll look at some further cases where that could be used later on in the presentation. I'm going to show you just briefly the AgAssure software tool, and what we're going to show you is how evidence from a producer could be loaded once and reused for multiple schemes. So let's just log into that tool. We're going to log in using the federated identity mechanism that Pure Farming provides. Now, that's not really a data exchange function, but as we've worked with data exchanges internationally, we've found that being able to at least optionally have federated identity makes life a lot simpler for producers. So let's just sign in there. And we're now looking at the farmer portal for AgAssure, where a producer can upload and show the evidence that they want to provide to multiple assurance schemes. And this particular producer at Cockatoo Downs is enrolled in 2 assurance schemes. They're enrolled in a scheme, and it's shown here with a yellow tag. It's LPA, so Livestock Production Assurance. That's a red meat program. This is the QA version of that program. So they're also involved in Sustainawool, which is a program for the sheep industry. It's operated by AWEX and the Australian Wool Exchange, and it provides assurance of quality and sustainability attributes for the wool products. And so the producers enrolled in 2 programs. These programs haven't merged. They're completely separate, independent programs. But what we have done is we've standardized the categories of requirements that a producer needs to show that they align with. And this is important because it helps producers to not have to replicate the information that they capture. And if I click into, say, the traceability category, I can see that there's a number of requirements that a producer needs to meet in order to comply with these programs. Some of them apply to both programs. Some of them only apply to a single program. And then I can provide evidence within these programs. So here are movement off records, and I can show the national vendor declarations. And I can upload evidence. I could do this from a mobile phone. I'm obviously doing it from a PC so that I can share my screen, but I can load an example national vendor declaration. This could be a photo or a scan, or it could be data from a tool that I'm using. I can upload that data. You can see it here. I can do all the usual sorts of things, zoom in and have a look at that vendor declaration. But of course, it's not just the paper documents, because we said we want to get beyond paper. So I want to go and show you that actually you could also load not just paper documents, but you could load photos, you could potentially load videos, and that's been used widely internationally during COVID, because it's been much harder for auditors or assessors to get onto farms and to certainly spend time sitting around the kitchen table. So being able to say to producers, can you load this evidence, and see that evidence loaded. So here I need to show that a stencil is applied to all bales, and if I click on one of these, I can check and make sure that the producer has indeed applied the stencil to all bales. So those are the sorts of things that that we could apply. Andrew, I'm going to click to the next slide and let you talk about these benefits.
Thank you, Andrew. So reinforcing the video at the beginning of the session, our discussions with the producers quickly made it clear to us that recording evidence and preparing for audits was really time consuming, even for the most organised of producers. And moreover, the producers that we spoke to made it really clear that the office was the last place they wanted to be, and they saw their time much better used outside managing their staff and operations. So being able to collect evidence once and being able to reuse it was really seen as a very positive benefit to using a data exchange. Also, allowing producers to collate evidence once and share it with multiple schemes could also significantly reduce the overall cost of compliance as well. So, if you think about having to collect that data from multiple sources and reproduce that again and again, there's real benefit for producers there. And furthermore, we heard that reducing the time and effort required to prove compliance could also potentially increase scheme participation and enable producers to participate in more schemes to increase their profitability. And similarly, there are benefits for scheme administrators as well, as they'd only need to work with a single source of truth, and they wouldn't be having to chase down data from lots of different locations. And with that, I'll hand back over to Andrew to continue the demonstration.
Brilliant, excellent. Lovely, thank you, Andrew. So, of course, that's all well and good, and what I've really shown you is it's just an application, and there are plenty of applications out there. Yes, this is one that might collect data for multiple assurance schemes, but it is really just an application, and we want to show you connecting data across a data exchange. So that's what we're going to show you next. And what we're going to do, AgAssure allows you to bring in connected data from other systems, and it does that by bringing in that data through the Pure Farming data exchange. So I'm going to continue through and connect my data, and there's really a couple of steps to this. In the first step, AgAssure, i.e. the software package I was just using as a producer, is going to ask me whether it is allowed to receive data from other sources. And it's going to tell me the reason why it wants to use that data, the terms and conditions under which the data is available, and the sorts of data that it wants to access. And so this is permissioning data out to an application from the Pure Farming Data Exchange. And so I'm going to accept access because obviously I was just using that application. I fully expect it to be asking me for some data. It's already pre-filled the property identification code, the PIC, and other things that it needs to get that data from. And so now the second step in the process really is to connect up the data sources that are going to provide the data into the data exchange. Of course, as a producer, if I'd already connected these sources, I wouldn't have to connect them again. But let's just imagine I haven't connected any of these data sources to Pure Farming before. What I'm going to do is it's found data sources that match the sort of data that AgAssure was looking for. And so I'm going to permission some data through from my MLA. Now, it's important to say this is not an actual flow of data live from my MLA, because that data was uploaded, the example data in this demonstration was uploaded to the MLA secure data portal individually by producers. But we're showing the process. So I'm logging in now to my MLA. I'm doing this once interactively, and then there's a flow here which is often called OAuth. It's an industry standard, software and industry standard flow that says, yes, Pure Farming in this instance would like to connect the data from my MLA, and it's going to connect these types of data. Am I prepared for this to happen? And as a producer, yes, I am. I want that to flow through because I'm trusting that once it's available for the data platform, it's going to be available for my assurance scheme. And similarly, I can connect this farm software here, and I can come through, do the same thing, log into the farm software, confirm the authorization flow, and that data can now flow through from the farm software to the data platform. And then once I've connected it from that data platform, that data will be able to flow through to the software that I've connected at the other end. In this case, it's AgAssure. So with that, I'm going to transfer back to AgAssure, and I'm going to hand over to Andrew to discuss what you've just seen.
Thanks. So producers and auditors told us that the main benefit from controlled access to evidence is that there's improved trust, and that this would make them more likely to participate in the schemes. A central data exchange could provide producers with a familiar, recognisable interface based on standard protocols such as OAuth that Andrew was just talking to us about in the demo, that provides clarity about what will be shared, with whom, and under what terms. Similarly, a familiar interface will also enable producers to control which third parties have continued access to their evidence. And finally, a central point of control that aligns with sources of data or aligns sources of data up with current security standards and governance could also protect against costly industry data security breaches. So now let's continue with the demo.
Brilliant. Thanks, Andrew. Okay, so picking up where we left off, that was great. We connected some data. What could we do with that data once we've connected it? Are we just going to see paper documents that are filled in with some data? Well, hopefully not. We want to show you that we can provide deeper insights by being able to bring in data from other tools. So we're back in AgAssure. And the data will have flowed through from when we connected it. And I'm now able to go into, for instance, my health records, animal health records, and I can show you some of the data that has been generated. So let's just dip into these. This is a treatment list. I'll make that larger so you can see it. And this is very much a representation. If I had recorded these treatments on paper, this is what they would look like. If I had run a report out of the farm software, this is what it would look like. But here are some differences. You can see that there's some fields here where the batch number and expiry date have not been provided. And so that's been highlighted so that an auditor or an inspector can see at a glance that that data is missing, or in fact, the producer can see at a glance that that data is missing. And down here, we've got some other data. We've got an expiry date for a product that has occurred before the product is used. And so it looks at first glance like a use of expired product. It may be that it's simply been misentered. But at least the producer and the auditor are able to quickly spot any issues and deal with those. So that's already richer than going through paper records, but I think we can do better than that. Let's have a look at another view of the same data. This is a product usage summary. So here what we're doing is we're rolling up and analysing the total quantity of product across a number of treatments during the season for sheep, and if any was applied to cattle, for the cattle on the same farm enterprise. And that's important because it gives us a view of where product has been used, and do those amounts look right for this size enterprise? Are those total quantities per head what one would expect for an enterprise of this nature? And we can look at some other things. This is a breakdown of treatments by month or over time through the season by stock class, and this is useful. And you may not be seeing a useful pattern here because the data is a bit synthetic from several farms. We just pulled it together, but you would expect to see some typical patterns of use. So you would see ewes getting drenched or treated, particularly pre-lambing. You would then expect to see lambs getting treated, the largest number of lambs getting treated at around weaning, and then that number declining as lambs move off to other farms or through the supply chain. And so as both producer and an auditor, you could see those patterns and say, are the number of treatments looking right? Are we seeing any gaps where maybe there's missing data? Those are the sorts of patterns you could start to look at. One final thing to show you, and this report has been quite popular with supply chains overseas, where they are concerned about antibiotic usage and the intensity of antibiotic usage. Obviously, most concerned about antibiotics which are important to humans, but antibiotic and antimicrobial use, full stop. So what we're looking at here is effectively a benchmark for the farm against a group of farms or a sector, showing where their antibiotic use might sit in terms of doses per 100 head or milligrams of antibiotic applied per kilogram of live weight of the animals on farm at the time of application. And so these are key metrics that are used internationally in terms of looking at antibiotic use or antimicrobial use. Great to be able to visualize that from farm software and then actually take that down the supply chain to see how that stacks up against other farms. So those are some examples of, I guess, richer use of data that's possible when you can connect it through a data exchange. Andrew.
Thanks. So during our conversations with producers and auditors, we heard that there are many benefits to be gained from access to insights. As Andrew has shown in the demo, evidence shared through an industry data exchange could benefit producers ahead of audits, mainly allowing them to take action to reduce non-compliance, as well as providing them with opportunities to benchmark their performance. This could lift overall industry compliance and enable industry biosecurity and animal health gains, as well as helping producers to show the great work that they do. Additionally, producer-provided evidence could be enriched with third-party data sources, further reducing time to comply, reducing non-compliance and improving overall data quality by aligning third-party data to industry data specifications created during the development of a program such as the AgriFood Data Exchange. It's back to you, Andrew.
Brilliant. I'm going to take a change of tack and I'm going to show you the sort of view that an auditor might have, or an auditing organisation, and a farm assurance organisation of one sort. And so I'm logged in here as somebody who is effectively an administrator for a farm assurance organisation. In our example demonstration here, I'm logged in administering Sustainable, and I've got just a few example farms loaded. And what you can see straight off is that many of these farms have not yet been assigned to an auditor for auditing. But if their turn has come, then we want to assign an auditor, and that auditor, in fact, will get an email notifying them that they've been provided access to this farm. So let's just assign Ron to that farm, and Ron will now have access to Creek Franklin and be able to go and access the data online, do their desktop review, take their laptop out with them if they need to do the actual audit. And then when Ron has completed the audit and confirmed that back, we can unassign Ron from that farm. And so the producer now has confidence that actually that auditor no longer has access to the data for that farm. I also want to look at one of those farms as an auditor, so I'm just going to go and do that. So I'm going to view my own assigned sites, and I've got a couple of them assigned to me. So I'm now going into Cockatoo Downs, which you saw before, as an auditor, and the last upload was a few minutes ago. So let's go in and view the documents for this farm. So I've got a very similar view to the view that the producer had. I can't upload evidence. I'm just auditing this evidence. And so I can see the evidence. The number of categories is lower because I can only see the categories that are relevant to the data that I can see. But I can go into, for instance, the traceability category. I can go and see those movement off records. And obviously there were many more documents visible on the screen, but a lot of them were not tagged to sustainable. So I can see the ones that are tagged to sustainable. I can go and see those wool bales and see the same view of the branding and the stencils that we saw previously. And I can go and see the same animal health and welfare information. So again, the picture here is that auditors are able to do their reviews at the desktop. They're able to do them, take the data with them and view it on farm. Or we often see hybrid audits. And again, that's what we saw very much overseas during COVID when countries were in lockdown, is that auditors could actually carry on going and doing inspections or audits, but they could do the bulk of their work using these digital tools, and they could contact farmers and say, can you make a bit more data available? Can you take a photo or a video of that? And it avoided the need to deal with the risks of the pandemic. Andrew.
Thank you. So speaking to scheme administrators and auditors, we heard that on-farm audits are costly but necessary. Access to evidence data ahead of inspection could really allow scheme administrators and auditors to reduce these costs by automating the data review and potentially statistically targeting non-compliance. So for example, the data held within a data exchange could highlight regions with higher levels of non-compliance and could be used to optimize auditors' schedules, reducing their travel time and saving costs. And this is something that can't be done without exchanging data. We also heard that while there were likely to be benefits, in the short to medium term, a data exchange could potentially be unlikely to reduce the number of audits required, as programs would need to be redesigned, and currently each program still needs to perform on-farm visits. However, in the future, we heard that there is definitely potential for auditors to be trained to carry out multiple audits for more than one program, and that evidence documents could be enhanced to enable use across programs to better support wider automation, such as scanning text. And these technologies that are often cost prohibitive could be, the cost of using these technologies could be spread across many programs. This could also reduce the number of farm visits required. And we also heard that from many interviewees that the industry data exchange operating and governance models could also provide a forum to support program collaboration. Again, something that we've heard is difficult today, just given the differences in programs and the liabilities, etc. involved. A data exchange would also enable auditors to request and review evidence before visiting a property. And we heard that this would allow them to spend much more time on farm, in yards, with producers, focusing on areas of non-compliance. And this would also reduce the impact that they have on farm operations by reducing the amount of time they need to spend at each property. And we also heard that there are benefits to sharing commercial and industry audit evidence, as overlapping audit schedules could reduce the time between visits and increase data quality. So a lot of the commercial audits that are undertaken by processors have a much shorter time between visits than some of the industry programs. Auditors collecting and reviewing evidence digitally could also reduce the amount of rekeying of evidence that currently occurs post-audit. So a lot of evidence that's collected on farm is taken back to the office by the auditor and rekeyed into different systems. And this could result in faster feedback to producers and also potentially quicker resolution of non-compliance. So with that, I'll pass back to Andrew now for the final part of our demo.
Brilliant. And look, I realise that in one sense time is passing by, and in another sense I'm kind of racing through these things. So there will be opportunities later on, not just to ask questions, but to see things in more detail outside the main part of the program. I want to just revisit this idea of using data across the supply chain, because at the beginning I showed a line where data went from on-farm technology through to supply chain partners. And we certainly, in our work in the United Kingdom and Canada and Europe and New Zealand, we see that flow very much so, but we equally see the opposite flow, right? Where information that is gathered by supply chain partners may be mixed or blended with the information from farms and fed back to producers, often through discussion groups or benchmarking within supply schemes. And I'm going to show you, I'm not going to do a complete demo, I just want to show you a couple of pieces of how that sort of thing might work. And I'll just switch across to yet another browser window. What I'm showing you here is the user interface within Pure Farming that allows supply chain organizations to manage their lists of producers that they interact with, to request data from those producers and to interact with that data. And so in this case, I've got a list of producers that I've synchronized in, perhaps from my supplier relationship management application that I use. Maybe I've loaded a CSV file, and what I can do is I can create a request that I'm going to send to those producers. And so let's just go compose request. And what I want to demonstrate here is the sort of underpinning parts of requesting information that work right through the whole of the Pure Farming data integration platform. You need to specify the purpose of the request. Why are you wanting to use this data? What's the purpose that it's going to be used for? You need to specify the terms and conditions that are going to be used, and ideally those are specified as a short, human-readable agreement with those key points. Of course, we know all terms and conditions have got to have all the legal boilerplate. That can sit behind or as an appendix or be emailed to producers. They do need the terms and conditions very simply up front to read and agree. I need to be able to decide what types of data I'm going to connect, and each of our themes of data contains a number of different resource types, so that you can get quite granular with how sets of data are permissioned. And then there is a mechanism here, because I'm going to ask them by email to specify how I'm going to communicate to them the purpose of using this data. If I was doing it from a software program through an API, there'd probably be a different mechanism. So I won't go any further into that. I could spend lots of time on it. We haven't got lots of time. I'm going to hand back to Andrew to summarize what you've just seen.
Thank you. So throughout our interviews, we heard many different scenarios where evidence shared across the supply chain provided benefit. And at a high level, easy-to-use sharing mechanisms provide opportunities for increased access to services, productivity tools, and advice. And this has wider potential benefit of increasing uptake of digital tools by producers, as well as also potentially growing the overall value of the agri-tech sector and driving benefits across agriculture. We also heard that current services could be enhanced through high-quality data, reducing errors and ensuring producers get the prices that they expect. And a good example of this that we heard was reducing errors that sometimes occur in wool catalogues would provide great benefit to producers in terms of getting the price that they think they're going to get at market. But there are many other examples. And finally, providing a data exchange platform that enables producers to easily share evidence of their best practices really does give them a platform through which they can be recognised for the great work that they do. And with that, I'll hand back to Andrew to wrap up.
Brilliant. So in theory, what we've showed you is how compliance requirements could be aligned, and the key benefit of that was saving time and reducing cost of compliance for program operators, for auditors, and for producers by reusing evidence and aligning those schemes so that the evidence was categorized and described in the same way. We showed you that producers could capture a wide variety of evidence digitally, and that involved everything from photos and videos right through to scans of paper documents. Importantly, we described how and showed how a data exchange or data integration platform supports the transfer of data between farmer tools and industry tools and other systems, and that one of the key benefits of that was to enable greater program participation, which is good for the programs, but especially good for the producers. We showed that producers retain the control of their data and that they get to permission it for the specific uses under specific terms. And that's all about increasing trust and making it easier to collaborate. And we showed how data could be leveraged to provide richer analysis and richer compliance across the supply chain that could otherwise be achieved. So thank you very much, and that wraps up our presentation.
Excellent. Thank you very much, Andrew. And Andrew, I think it was a fantastic presentation. It's our first view at a solution to what some of this data exchange we're talking about, what it could look like. So absolutely fantastic. Thank you very much. We've got about 10 minutes for questions now, and I've got a number of questions coming in the chat here for you. So I'll just have a go at reading out some of them. There's a question from John Elfrink. How are the systems permissioned? Is there some form of zero knowledge technology applied? If so, how is it applied? And are some forms of smart contracts applied?
Yeah. And this is an interesting question. I'm not going to go too deep into the tech. Suffice to say, there are a lot of ways that these things can be done. In pure farming, we're using slightly more traditional technologies. So we're using locked down databases that have got effectively what's called zero privilege, which means that you can't just go in. It doesn't matter whether you're going through the front end or a back end, you can't see any more information than you're already permissioned to see. And so that deals with a lot of the filtering. By the way, that's quite hard to do at scale and in a way that's performant. And we've certainly over the years had some learning and struggles behind that, but I think we've got it working reasonably well now. Smart contracts is exactly where we think the industry is heading. Right at the moment, we use a form of what's called user managed authorization, or UMA. UMA itself is a standard or an RFC that's put out by IETF, the Internet Engineering Task Force, but it's not complete, and so it's still at the discussion stage. We've had to extend it to do what we needed to do in that area.
Great, thank you for that. Flavius Despy has a question. Given the permission data sharing that you've already implemented here, what additional benefits do you expect to get from the AgriFood data exchange in this scenario?
Yeah, indeed. It's probably worth noting that in all the experiments that you'll see today, we're showing you data exchanges, but we're not showing you the Australian AgriFood data exchange because obviously that's not yet in place. We're showing you what's possible, and I guess exploring the business case and the benefits and the challenges to be overcome. And so we're using a permission data exchange called Pure Farming, but you could imagine that that's a proxy here for the AgriFood data exchange, and maybe an example of what could be done.
Yeah, exactly. Thank you for clarifying that. That's good. Gabby Saragra has a question. Thanks for a great demonstration. Does this experiment represent moving from a process that has little digitization to digitization, or is it that the process is currently digitized but in separate systems? I hope I got that right.
Yeah, great question, Gabby. And the answer, of course, is both. So you certainly saw photos of things and photos of scanned forms, and it would be true that for probably a majority of producers still, the process is not even digitized. They would love it to be, but there has been traditionally many barriers to that, not just all the obvious ones around internet connectivity and those sorts of things, but just the investment that industry organisations need to make in terms of digitization. It's quite substantial. I think what we're seeing is that there are also lots of separate systems, and we kind of want to encourage that, right? We want innovators in on-farm technologies and software to be creating lots and lots of tools that each do great things and producers can mix and match. But we also want all of those to talk together.
Yeah. Good answer.
It's probably worth also just saying that a big part of this is also around consistency of experience. So by introducing an Australian-wide AgriFood data exchange and providing a consistency of experience, we're also looking at the opportunities that could also drive digitization as well.
Great, thank you, Andrew. And Andrew, another one from John L. Frank, which I think is a great one. Once the data is in the system, who owns the data?
Yeah,
we saw this coming.
Yeah, we did, and it's a really pertinent question, John. And everywhere I speak, producers are always the first to ask those questions, and then so do people from industry organisations. And let's put aside the kind of discussion around ownership and are these facts and can they be owned or not. We know what we mean, right? When we all talk about ownership, we mean who controls the data, who's got the right to say what happens to that data. Our starting model, at least, and I think my observation from talking with the industry people involved in these experiments, and you probably heard it in the panel discussion earlier today as well, is that the general accepted thing is that the producers own the data about their businesses. Yes, there's some edge cases. There's some edge cases where, hey, if you're a meat processor, then the carcass data is about carcasses you have bought before they became carcasses, and you probably own that data, but you're making it available to the producer. And because it's also about their business, they've also got some rights in that data. So certainly from our model within Pure Farming, that's exactly what we put in place. Our terms and conditions say we don't own any of the data in the system. It's not ours at all. We're simply providing a connectivity mechanism. It's the producers who control what's done with the data.
Really good answer. Thanks very much for that. And Research team, do you guys have a view on the value of the benefits on audit optimization if the processors were to also engage in the use of the solution?
Yeah. Andrew, you might want to start with that one.
Yeah, I will do. So at the moment, that's something that we're working through. But we've, as I said, when we went through the benefits, we can certainly see that there is significant benefit in terms of bringing together those audit programs. At the moment, like I say, we're working on the economic side of what that would look like. But the short answer is yes, there is benefit, and I think both the commercial, so the processor programs, and also the industry programs both see the value of that collaboration.
Yeah, and I'd probably just add, in my discussions with processors in several countries, they can see the benefits if they were able to share in and get involved in that. They also want to make sure that there is an appropriate arm's length between them and the assessment of compliance, and so that's why they typically use third-party auditors and audit programs. But being able to participate in that and see some of the data flows or provide data in to support that both compliance but also increase in compliance from producers would be very useful.
Fantastic, excellent. Look, I do think it's a matter of real. You go. No, please go ahead, Andrew.
There's a bit of a delay, isn't it? No, I was just going to say that one of the areas that does need to be considered in this is liability, and this was one of the things that I think we as a team learned through the experiments, that there are certain considerations such as program liability that need to be considered when bringing together audits, bringing together evidence, etc. as well, which are not insurmountable, but are going to take a little bit of time to resolve.
Great, thanks so much. Look, we've got 2 minutes left, so I'm going to give you one last question from Cherry Rakutuarivelo. Sorry, Cherry, probably didn't get that right. On the data flow slide from Andrew, does AgAssure or Pure Farming Platform allow the data to be treated to remove some sensitive information depending on the application scenario? For example, compliance might require sensitive information that should not be available for ag assurance schemes. Yeah, that's a good one.
Yeah, that is a good question, Terry. And the necessity of presenting this in just a few minutes per snippet, it means that you get a highly generalized version, including the generalized diagrams. It's probably worth saying our model for dealing with the data, I talked about standardized data schemas or specifications earlier. It's worth saying that we see those at a relatively granular level, which allows you to split apart some of the data structures and say, well, this is sensitive information and this is not. And so they become different resource types, and you can permission those separately. So the data can travel together or it can travel separately.
Great. Thank you very much. And just a reminder for those of you that didn't get your question answered here, there is another chance tonight that when we do the breakout sessions, you can dial in and ask, chat to Rezair directly. But thank you very much, both Andrews. That has just been absolutely fantastic. A really great presentation, and thank you for engagement in the Q&A section. And just finally from me, thank you to everyone involved in the compliance experiment. It has been absolutely incredibly interesting to be part of that journey, and I really appreciate everyone's involvement, and not least all the work Rezair has put in. So thank you, everyone. I'm going to now hand back to Andy, I believe, for the next session. Thank you.
Thank you very much, Irene. And folks, what we're going to do now is just run a short Mentimeter session. So, Georgie, if I can get you to share your screen in the Mentimeter, you'll see, folks, coming up on your screen now is a QR code. If we can get you with your mobile phones to log in using that QR code, or you can go to www.menti.com and enter the code that you see there on your screen, 66326486. Once you have logged in with that code, we can start a series of questions. We have 5 questions that we're going to ask you. We're going to try and get through it very quickly if we can. I know there's a lot of you online. We'll be able to see the numbers count down. So Menti is a live interface where, as people respond, we see the numbers of the responses ticking up. So I can see people entering into Menti now. So either use that QR code with your phone, or on your phone log into www.menti.com and enter the code you see on screen there, and it will take you in to the Menti. All right, so I can see the numbers building. What we might do as the numbers start to escalate is we'll move to the first question. So Georgie, if you can flash that on screen now. Here we go. So folks, for the first question, and just enter it into the relative field on your phone that you will see, what are 3 words that describe the demo you have just seen? So what are 3 words that describe the demo you have just seen? So enter away, folks. And as you enter, we will see the information starting to appear on the screen. Here we go. Insightful, practical, interesting, inspiring, product of collaboration, useful, practical, data sharing. That's fabulous. We'll give you another 30 seconds on this one. Now, in some cases, during these Menti sessions, we are using the information to gauge sentiment, and this is a fantastic way of seeing this. Practical and interesting, useful and relevant, all coming up as really strong themes, informative, which is super. And in some, we're going to be asking you for comments and feedback as well, which we'll move into in a second. So just another 10 seconds on this. Okay, sensational. Thank you, folks. All right. Useful, interesting, relevant, informative. Let's move, Georgie, into the next question if we can. So thank you for your comments on that. I think if you think about that use case, I think this use case could add value for the focus industry, and you just slide your position wherever you want to go, and governments. So for the focus industry and for governments, from not at all on the left to materially on the right, I think this use case could add value for the focus industry and governments. And we can see the sliders jostling for position as people enter their feedback. So 2.7 out of 3 for the focus industry, which appears to have nailed it, and then 2.5 for governments, which is terrific. All right. And we've had a few more enter, and the positions are staying relatively the same, which is good news. So Georgie, we may move to question number 3, which is to improve and enhance the benefits or user experience of this type of application. What would you recommend be considered? And if we can get you to enter your text into the field you have there, and just try and keep your responses relatively short, and you'll see them start to appear on the screen in a moment. So to improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? So mobile app, data visualization, dashboards, easy on-ramps for data distribution or data contribution. And this information, folks, will be used beyond this session to help us in the validation and development of the business case. So quantifying potential value, clarity around data ownership, flowcharts, data ingestion from lockdown systems, simple access, simple agreements. So some themes starting to emerge here, especially around the mobile app area. So we'll just give you another 30 seconds, folks, to continue your responses here. So knowledge graph, dashboard, simplicity. Mobile apps again and dashboards again coming through as a common theme. Simplicity also coming through as a common theme. All right. Fantastic, folks. Thank you for your thoughts. There are some really strong themes starting to emerge through that. Georgie, let's move to the next question. How likely would you be to use this type of application if the Australian AgriFood Data Exchange made it available? And down the bottom there, you've got, it's not applicable to me, unlikely, would likely adopt, or almost definitely. And although we have said this particular application was to the use case and industry it was targeted at, we're saying broadly this type of application, if you could think of it across other areas. And we'll just give this another 30 seconds as well. And likely and almost definitely are starting to creep up. All right, another 10 seconds to finish your thoughts on this particular one. All right, folks, thank you for your contribution to this. And Georgie will go with the final question. Thanks. All right, which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? So once again, just type your ideas into the field. We'll keep the information as succinct as you can. Which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application as our final question? Grain's already coming through as a strong theme. Beef, red meat. Horse traceability in there. Horticulture coming up. Grain is a solid one. Any with a consumer food product downstream. Very strong for red meat and grain. All. Seafood, fisheries. Dairy has come up as a theme. Poultry, seafood. Yeah. A broad sweep by the look of things. Okay, folks, just 30 seconds to see if you can finish up on this one. I've got a little bit of interference on screen. Apologies for that. Okay, that's clearing up. All right. That's the theme of all industries starting to come through as well. Any with a high compliance or regulatory load. So folks, just last 5 seconds to tie up in here. And well, thank you for that. Now, just before I introduce the next session, we have had, Kate has been capturing some of the thoughts from that last debrief in a scribe. I just wonder if we have access to that scribe on screen. Here we go. So we're also taking for each of the demonstrations today a digital capture of the Q&A and the introduction sessions. So this is Kate's first scribe on the first session, and one will be available after each. These will be available to participants later on. Our second demonstration for the day is going to be introduced by the workstream chair and the head of the School of Research at Charles Sturt University. It's Professor Marta Hernandez-Hover. And so I'll hand over to you, Marta. We'll get in.
Excellent. Good afternoon, everyone. I hope you can hear me. Good. Someone can confirm. It should work. All right. Thanks everyone for joining today. Look, I'm joining you from Wiradjuri country in Wagga Wagga. As I said, my name is Marta Hernandez-Hover, and I'm a professor at Charles Sturt University, working in the area of animal biosecurity. In the last few months, I have had the pleasure to work with the Biosecurity Working Group, and as has previously been described, this second experiment is focusing on biosecurity in the viticulture sector, and the main aim is strengthening biosecurity using standardized and accurate traceability data. Hopefully you can now see the right slide, so we can go to the next slide. Thank you. So as shown in this slide, and for those of you who are not familiar with this experiment, the pain point which the solution has been designed around is in relation to the support of the management and control of the incursion of emerging and significant biosecurity threats affecting or that could potentially affect the sector. So things such as, soil-borne contaminants, as phylloxera posed an ongoing threat to free zones, and exotic pests like Shillelagh also pose a significant risk if introduced into the country. So identifying these threats and controlling incursions effectively requires a coordinated national effort. However, currently movement records, such as those of machinery and people, only exist in silos and are predominantly paper-based, with sharing information relying heavily on manual processes. Therefore, the characteristics of the current system could potentially pose difficulties for collating information for tracing purposes in a rapid and effective manner in the event of a biosecurity incursion or outbreak. So the current experiment aims to integrate and consolidate data from existing movement records of grey matter, people and machinery, and in some instances digitize this data where necessary to develop a digital view of cross-jurisdictional movement, supporting the efforts to trace these movements, to identify the origins of a biosecurity issue, and better management of biosecurity events and outbreaks. So the success criteria for this experiment, you can see them here on the right-hand side of the slide, include, the consolidation of data that will support incursion modeling and a rapid response. And these include support area freedom maintenance, pest containment and eradication, which at the same time can provide assurance for market access. In addition, such system, will improve the ability of producers to reduce the administrative burden, transition away from manual processes, which would facilitate logistical optimization, and then, of course, access and share relevant information for biosecurity planning. So we have worked closely with a lot of partners in the working group to access data for the experiment. And the key partners that have been able to share these data have been Treasurer Wine Estates, Vine Health Australia, Biosecurity SA, and Agriculture Victoria. So in addition, if we go to the next slide, you can see that we had engagement and support of a broad range of stakeholders that you can see here, including New South Wales Wine, Wine Australia, CSIRO, and others like MLA, FIAL, New South Wales Department of Primary Industry, Western Australia Department of Primary Industries and Regional Development, Charles Sturt University, DOR, Australian Wool Innovation, and FIDC. So with that, I would like to pass now to Odette Young, Steve Taitoko, and Quinton Wolf from Eratos, who will take us through the experiment approach and the demo. And please, just keep putting your questions on the question and answer box, and we will address those at the end of the presentation. So thank you. Back to you, Steve and Odette.
Thank you, Marta. My name is Odette Young, and I am a digital producer at Eratos. And with me presenting today is Steve Taitoko, our CEO. So what we're going to cover off today is just to talk about the problem space in the context of this experiment in a phylloxera incursion, and also to touch on some of the main points that we have come across in our discovery phase, and then touch on our approach. We'll then demo what the solution could look like when we would have a data exchange set up, and then show what would happen in a phylloxera incursion, how we would use the solution to improve the handling of a phylloxera incursion. So just a little bit of a background of this project. We started in mid-December. We conducted interviews across the value chain, and we ingested sets of data sources across the supply chain. So we want to acknowledge and give huge thank you to Inka Lee from Vine Health and Ben Harris from Treasury Wine Estate. Thank you so much for your being so generous with your time and your data. Without you, this project would not have been possible. And a big thank you to Vicky from Square V, who conducted the interviews for us. And as well as Marta, you and your project team, thank you very much for your support throughout this project. So as a data platform provider, this is the lens through which we approached this project. So to kick off, we'll try to articulate this very complex problem space. So at present, managing a phylloxera incursion is incredibly challenging. It's hampered by slow and incomplete access to critical data that is needed to make decisions and to manage an incursion effectively. So where we would like to get to is this industry-wide data exchange so that we can allow for a better response during an incursion, improved access to data, improved processes, and this would ultimately result in far better biosecurity outcomes where the incursion is managed and minimized effectively. So in order to get from where we are currently to where we want to be, there are a few factors that came through in our outcomes, in our discovery outcomes, that would need to be considered. So there, the first one being anxiety around sharing data. So there are varying degrees of comfort with how data is used and how it is accessed. So this was very clearly demonstrated in the varying degrees of difficulty in obtaining data for this experiment. So the solution needs to allow for customizable permissioning and sharing, as well as clear ownership, to build that comfort and alleviate that anxiety around sharing data. The second outcome that we had was around the comfort that growers have with current processes that are working for them. So they know their manual solutions, they're comfortable with them. And in our interview process, we also learned that there is a concern over downtime. In a busy harvest period, we can't afford for digital systems to fail. So the solution needs to be easy to use, robust, integrated. The growers do not want to use a completely separate system, and preferably capture data passively where possible. The third discovery outcome that we want to highlight is biosecurity alone is not enough. So biosecurity isn't necessarily the biggest problem facing growers and not the most immediate problem facing growers. So when positioning a solution like this, it is really important to outline the broader economic benefits to multiple parties along the supply chain. So in so doing, one would unlock sets of data and grow that ecosystem and grow the benefits to a broader range of users and use cases. And then lastly, the scale and variability of the data is enormous. So there are multiple vectors involved in a biosecurity incursion with multiple connections to things that would neutralize a vector from spreading a biohazard. And just looking at trucks alone in a harvest season, you're looking at easily 100,000 truck movements in a season. And when looking at phylloxera specifically, one needs to access 7 years worth of data to fully handle the incursion end to end. So it's a lot of data that one needs to access when managing an incursion. So when looking at these 4 key outcomes, 3 are actually social and about how people feel about sharing data and how they feel about their current processes and the priority that biosecurity is given along with everything else that they need to worry about day to day. and only one is actually around the technical architecture. So we're looking at a social as well as a technical problem here. And then something else I wanted to touch on, which is something that we are seeing in other similar projects and with clients in the agri space, that is this theme of trust. And we are busy running a project with the University of Melbourne where we have interviewed growers and asked them, in the context of data sharing, what is their main concern? What is that main thing keeping them from participating in a broader data sharing environment? And trust came through as such a key theme. It's trust in what the data will be used for, privacy and retaining custodianship of your data. So that is something really important to keep in mind when we're talking about the solution. And also a reason why we engaged Vicky in our experiments and in running those interviews. She has a high trust relationship already built in the industry. So just looking at this trust feedback loop, to start participating, we need to reduce the perceived barriers of entry, and trust being a key one. So by participating and sharing data and then seeing value and building trust, data sets can be built on and further value achieved, and enhancing that ecosystem of data through building trust, building value, and sharing additional data sets. So how do we start that process? So a couple of thoughts is considering trust by association. So getting third parties involved, examples being your grower groups, other producers, or wineries that are respected in the industry. So getting parties on board that growers trust. And then also trust by exposure and familiarity. So starting small, a sensor costs $500. So a small capital output of a few sensors, start getting value, start analyzing data and seeing benefits on your own farm. And that opens up the gate to start sharing. So why is trust relevant? Because it is such an important component, we used trust as a lens through which to look at our solution. Trust is embedded in our operational design and the ecosystem of Aerotos. And I'm going to hand over to Steve just to chat around how we build trust with our distributed architecture.
Thanks, Odette. So we'll just give you a bit of a peek under the hood of the Aerotos technology, and also give you a bit of an overview to the type of solutions we're creating and how we're approaching this problem. To just give sort of a zoom back out for a minute, we designed Aerotos primarily as a tool by which we can make decisions around the climate and around biodiversity. And so our belief is that if we look through both of those lenses, we can make far better decisions. And obviously within the agri-food space, both of those have and will have significant impact in the future. But solving for those means that we've actually solved for some of the most complex data on the planet, which means that lots of other data can then be layered and start making decisions. So how do we do that? For us, it was about how to create a distributed platform and not a centralized platform. So there's a need for all three of these. So you see a lot of centralized, bring the data in, put them in a database, manage them centrally. You're seeing a lot more decentralized, particularly through the application of blockchain type technologies. But for us, we wanted to design for a distributed network, and there's a bunch of reasons why. But if you take the trust lens, fundamentally, we want to leave the data in situ. We want to leave it on farm, if providing this decent broadband access. We want to be able to have access to very large data sets that are very hard to move around. And therefore, from day one, we set out to design a distributed data platform. Then from when you have that in place, you have the ability to then look at how you then structure your data. And to that end, Adit, can you move to the next slide, please? I don't seem to be able to get the thing moving along. To that end, when you look at the way in which this particular ecosystem is designed, there's lots of different actors, there's lots of different data sets, there's lots of different software, there's lots of different hardware in operation. And for us, it's fundamentally important that we link all the different bits and pieces so that we can actually start applying logic and context to the data. And it's the context component that we believe is super important to any type of data exchange. So in this particular example, you can see the various actors that we've been working with. And from a trust perspective, you look down the right-hand corner, a farmer or grower can participate through similar technology, but only when they choose to provide data to whatever party they want to provide data, they can actually access into the data exchange. Likewise, there's other sets of data that might be important to decision making, such as weather data or climate data, or even ecological data to assess biodiversity risks and challenges. So when you look at that from a distributor point of view, that's why we went down that path, and we believe that it's necessary to have as a fundamental component, because the data's everywhere. It would be a massive task to try and centralize it all. And in fact, you lose all the efficiencies, you lose the power of the permission data. And again, through that lens of trust, this is why we believe the way in which you have a distributed data exchange allows you to maintain control over your own data sets and share. So with that in mind, just in terms of our particular business, the value propositions that we're most interested in are things such as consistent licensing terms, easy commercial engagement, the ability to create innovation in and around a data exchange will only be through the ability to scale. And it's only at scale that we can actually start to make the impact. So we're not going to get to a $100 billion industry unless we can actually scale the solutions. So really, it's this fine line between being able to have lots of bespoke solutions, but ultimately we want to aggregate all that up and do it in a way that's highly efficient so that we can scale. So for us, the way in which you do that is you create communities, and it's through the communities that we can start to get the right people around the table to have the right discussions. And as Odette spoke about the social architecture, it's through that we start to solve some of the social problems or social issues that we have in terms of being able to design through change, particularly, and getting people to adopt new habits or new behaviours. So how do we create incentives to change behaviours? So for us, if you look at this example, it's about building on top of, it's about building up, and it's about collaboration. And this is a technical component to doing this, but effectively with a technical fabric that allows you to seamlessly and efficiently move the data around and access with the correct permissions to be able to build tools and products that then transform that data into something meaningful. It's through that you can then engage at a community level to then start to build on top of, and then each actor along the way is able to derive their own benefits and their own value. And it's through that you start to be able to figure out what types of incentives you want to put in place to then change the behaviours and motivate new actions. So I'll leave that there, and I get back to take into more specific around the actual project or experiment we conducted. Thanks.
Thank you, Steve. So we'll go through our approach to the experiment, and broad strokes. We'll touch on the data that we had to work with. We gave that data context. We created access to that data, and then we're able to demonstrate an example of something that could be built on top. So just to touch on the data sets received across the supply chain, I'm not going to go into everything in detail, but as you can see, it was varying degrees of some digital, some paper-based. But what I do want to talk to and call out on here is the grape dispatch dockets, which were pivotal to our solution because they allowed for a linkage between various data sets. So the kinds of information that you would find on a grape dispatch docket is where the grapes have come from, where they're going to, which truck is carrying them, the weight, the date, etc. So that information is pivotal to creating meaningful connections in the data between the fields. And as you can see there, it is paper-based. So that does call to the need for a digitization and a technical solution. But then there's also the fact that capturing grape dispatch dockets is a manual and known process. So even if you went through every single data point, there still is a people aspect and a technical aspect to even just looking at one subset of the data. So we took all the data in the various physical formats and layouts, and we then analyzed it to make sense of what we received. And I know this is very, very busy, but just to illustrate the varying formats and layouts that we received the data in. And we mapped out how they all relate. And this surfaced the elements that are relevant to the problem space. So for example, locations, people, equipment, those kinds of things and how they are connected. We then took that and we created a technical solution to house all of that data in a meaningful way along with their relevant connections and metadata. So why this is important to talk to is that this structure was made to be completely agnostic and scalable. So, for example, this farm table in the top right-hand corner would house fields like farm type. So in this context, we're dealing with a vineyard, but this structure could very easily house mangoes or lamb or beef or any kind of other sector. And there's also, if you look at the pink tables around biorisk vectors and blockers, again, it can house any biorisk, and there's linkages between that and the vectors associated with the biorisk and the blockers that would neutralize a vector from spreading a biorisk. So we looked at this in a way that would make it agnostic and scalable and be able to house information from any sector. So after going through that exercise, we then look at how to access the data. So this is a screenshot of the Eritas platform. So this is where one would log in and be able to explore and interact with the data that you have permission to access. So this is what the team would have available to them in this experiment and what they would then have available to them to build a solution on top of. So for example, if I look on here, you'll see I'm searching on viticulture and I've got a filter for biosecurity, phylloxera and boundaries. So this is brought through all the data sets that are relevant to what I've searched on. So this is why it's really, really important to have that logic sitting in that data structure of what connects with what data set and what is relevant to the elements that you are wanting to understand. So when I go, and then so from here, the team were able to build a solution on top of this data set. I'm going to share my screen now, and we'll have a look through what we built. Okay. All right. So just before we jump in, this is all the data as received. We've anonymized to remove any sensitive data, but otherwise this is as received. So we have two locations, Wendy's Winery and Smith's Vineyard. We're able to overlay wine regions on top of that. So here we have Riverland and Barossa wine regions. And we can even go one level lower and look at parcel data. So that will show us the actual blocks associated with the wine regions received. So this is an example of 3 sets of location data that we can work with to give the data context. So now we can get a taste of the movement and sign-in data that we received. So part of the data set was GPS coordinates or GPS tracking for trucks. And we also received who's on location data for people signing in and out. So I'll let this run for a little bit and just show some sign-in data on Smith's Vineyard. So this is people checking in and out of Smith's Vineyard. So if I pause and hover over one of the data points, you can see that there is data associated with this entry. So we've anonymized it, but names, email addresses, organization, etc., etc. And this can be enhanced with any other data sources that could be added to the ecosystem. If we zoom out, we can have a look at truck tracking data between Smith's Vineyard and Wendy's Winery. So that's illustrating some truck movement there in real time. And again, if we pause and hover over the data point, there is information available pertaining to the truck. All right. So essentially what we have here is we have geospatially assessed all the data layers available within the current system. And we are visualizing what is available by doing so. So we can understand the scale of data at play and how it relates in reality. So it's important to make sense of the data so that we can design solutions that are meaningful and relevant. And this is a really small snapshot of the data that is available and of the data that we were able to work with in this experiment. So the approach up until now is to just illustrate how we can work with the data, how we can make sense of it, how we can give it context and structure, and show the groundwork for producing a platform. So to round off our approach with the foundation of track and trace data, which underpins the solution for incursion handling. Because to manage an incursion, we need to understand how the vectors have moved on the locations that we are concerned with. So to reiterate, this is a demo of a tool that anyone can build on top of the data exchange. The data is structured and distributed, meaning that it stays in the hands of who owns it, and it is shared as is appropriate. And anyone can build a tool on top of the data that they have access to on the platform. All right. We'll now cover off how this track and trace data can be used in an incursion scenario, and we'll discuss how that same data is the basis for additional value adds that can be used for broader applications across a range of participants without the need to collect a completely separate set of data. So let's cover off from a biosecurity perspective what this data can be, what we can use the data exchange for. So just from a phylloxera incursion standpoint, just to cover off what actually happens currently, phylloxera is detected in a vine and the vineyard borders are closed down. Further investigation is then conducted, and in most cases, a 5-kilometer radius is then applied to the border closure. So what this means in reality is to manage this, it is an enormous data request. I touched on all the vectors that are involved in the winemaking process. You've got trucks and people movement and equipment. There are a lot of data points during just one harvest season. So it's an enormous data request. And in a phylloxera incursion, you are needing to look at 7 years worth of data. It's incredibly laborious and time consuming to access all of that information, particularly if it's physical documents. And it's also potentially incomplete if not all records are available. So the future is a data exchange with all of this information incorporated in a digital capturing and available digitally. So I'm going to jump back into the presentation. We're not sharing. Okay. All right. So let's cover off. All right. So we've added a few extra locations. And we have an incursion detected on Sarah's vineyard. So let's walk through what would happen in this case. So we've taken the existing structure that we have and we've augmented it with additional entries just to illustrate the magnitude of movement data that is involved in an incursion handling, and this we've represented spatially as well. So we have an incursion in Sarah's vineyard, and immediately a 5-kilometer radius is imposed around the vineyard. So other information that we would want to understand in this context is the phylloxera zones. So we've overlaid an example. This isn't real. There is no phylloxera in this area. So this is just an example of what it could look like. So red being a phylloxera infected zone, yellow being a risk zone, and green being an exclusion zone where there is no phylloxera currently. So we created a set of data to illustrate the volume of data that is applicable in an incursion scenario. So if I run this, I'm just going to run the simulation just to show a very small kind of subset of the movement that one would experience. So the purple is equipment, white is people, and black is trucks, for example. So we're seeing the movement of all the vectors in and out of the incursion site. So, for example, we've been able to include sensor data on trucks in our data exchange in order to see this. So a few things that we might want to understand just off the get-go is movements from a red zone into Sarah's vineyard. So what are the potential origins of the incursion? Where did it come from? It must have come from somewhere where we are aware that there is phylloxera. Or movements out of Sarah's vineyard to a green zone. So we know that harvesters are high risk vectors for spreading phylloxera. So if a harvester has left Sarah's vineyard and moved over into a green zone, we would want to act on that as soon as possible. So we can query the data to understand and augment this with logic. So this is why logic is really, really important, because we can apply rules and events to the data. So we can look at things like general compliance. So we know what the policies are around the management of different vectors and blockers in an incursion scenario. So we can run a query to understand general compliance. We could also add onto that ratings for suppliers. So suppliers that are highly compliant to regulations, or maybe some that need a little bit of training or upskilling. We could even write in conditions to highlight lines in red that are high risk vectors that we need to act on sooner rather than later. We could heat map particular areas of interest if we find that a lot of vectors have moved off the incursion site into a particular area. Maybe that area becomes high priority to act on. And we could also look at particular vectors in isolation in this data set. So there are various ways you can slice and dice the data depending on what it is that you want to look at and how you would like to act on the data, using those underlying contexts and linkages in the data. And then there are various outputs and products that can be built on top of that. So it could be as simple as a contact list of who do I need to chase up on or inform that we have had an incursion. I could apply additional logic to that and prioritize those contacts. It could be an automated alert to your cell phone if you have moved across zones and, for example, if you're a harvester contractor and you are moving across zones and you need to go through a heat shed before you continue. So allowing for self-monitoring and automating alerts would be very beneficial. So the many different uses for this data in this format. So how do we, So how do we get the system in place? So one of our key insights is that biosecurity is not enough. And how do we provide those additional incentives to share and become part of this ecosystem? And we've also identified that this track and trace data is useful in other spheres and other sectors, but with other use cases outside of biosecurity. So how do we position this as more of a value, as having more value than just biosecurity alone? So I'm going to hand back to Steve to round off.
Thanks, Odette. So again, coming back to the whole idea that if we can adjust and modify or create new incentives to change behaviours, the key insight that Odette shared earlier around biosecurity, not in of itself not being a large enough problem to justify the expense to build the systems. We also looked at a number of other areas where along the supply chain or the broader value chain, who might participate in funding or being able to make data available that already exists to fill in the data gaps that we have at the moment. So I won't go into each of these, but for example, we're doing a lot of work with banks and insurers in the broader context of a changing climate and biodiversity. And we know from them that they're willing to start putting incentives in place to be able to start getting access to data. So, for example, there's a lot of action around carbon credits at the moment. So being able to access accurate soil data or accurate tree canopies and the information that's required to validate that the right the carbon is being sequestered in the way that it's that someone's going to get some sort of economic benefit from. Clearly, once that starts to happen at scale, there's going to be a lot more sensors and satellite analytical capability and drones flying everywhere. So it's not going to be solved just by going out and spending because we want to put sensors on bins and trucks and equipment and people to solve for biosecurity. However, we know coming down the pipe there's a whole bunch of external macro forces that are going to either be required through legislation, so such as market access. So we already have a lot of sustainability reporting, particularly in the EU. The next one coming after that we know is net zero reporting. So how are we decarbonising? And the EU is talking about putting in place tariffs. So we're going to have issues in place, in particular in Australia, if we don't or if we can't start to secure clearer understanding in terms of how our nation or our economy will decarbonise. So from our point of view, it's not an if, it's a when. And I think in the not so distant future, and given that technology is increasingly more accurate and becoming less expensive over time, therefore they will have a lot more capability to gather data in ways that we can't at the moment, and do it in a way that again is safe, it's transparent, but will ultimately allow the data exchange to start lighting up, because the increasingly view that across the supply chain, up and down the value chains, across each sector, there's going to be incentives for everyone, every participant, to start to invest in the systems and the technologies to start tracking it, as well as the regulation is coming to enforce part of it as well, to also start changing behaviours. So we'll leave it on that happy note, and happy to take questions. So thanks, Odette, for taking us through it.
Excellent. Thank you very much, Tim. That was an excellent presentation, and hopefully everyone really enjoyed it, which for sure I did. Look, we do have some questions on the chat, so I've got them on the site. And thanks for those who posed some questions. So one of the first questions, there's several questions that relate to the social aspect that you talk at the beginning of your presentation. And one of the first questions that I've got here is, you know, Nate Kinch would like to better understand the trust feedback loop, and you know, a bit more explicit detail that backs it up. And then he follow up with a question on actually, what do we have a specific definition of trust?
And you can take the first part, and I'll take the second one. Are you on mute?
I don't think we can hear you, Odette. Yeah, we can't hear you.
So trust came through as a recurring theme throughout this experiment, and not only in this experiment, but in our business and in a lot of projects that we are working on, and clients that we have who are in the data space in agriculture and are working on breaking into these kinds of data sharing ecosystems, as well as the University of Melbourne study that I touched on. So it's something that has come through very strongly in many, many facets of different avenues that we are dealing with.
Yeah, and on the question of definition of trust, we don't know. You know, ultimately, I believe that it's, if you create the tools and mechanisms, the environment, people will form their own view around trust. And you know, I think fundamentally, from a data point of view, it comes back to provenance. You know, if you can understand where it was generated, why it was generated, how it's applied, who's using it, for what purpose. You know, so basically, what's the upstream and downstream factors that have gone into the data that's been used or applied, and the algorithms and the processes that are used to transform it. If that's transparent and we've got the provenance around it, then you know, I think the notion of what is trust will start to dissipate, because people can then apply a lens, whatever lens they want to, in terms of what's relevant for them. Is it trust around the ownership of the IP? Is it trust around the use of it? Is it trust around you know, how it's going to be, you know, applied to particular outcomes? So I think it's very personal, but ultimately, if you get the architecture and the social, the social and the technical architecture right, then trust is something that can be personalized, and hopefully through the design of the platform and the services that sit on top of the infrastructure, you'll be able to, you know, dissipate the lack of trust or the mistrust.
Yeah, thanks, Steve. Thanks, Odette. I think trust is a very, you know, big topic, and there's not a straight answer, isn't it? So there's another question from Nate. When you were presenting the demo, is this data then surfaced in some end consumer context? So, example, you know, is it an app at a point of sale, for example, that supports consumer decision making?
Yeah, I think what Odette showed, and we specifically didn't want to show the platform itself. We wanted to treat the experiment as if our internal team was an external creator, and what's possible when you have access to a data exchange. So the tool that they use is an open source tool, and it's the whole premise is that you could build whatever you wanted on top. So Nate, to your question, you could build your own app, and I think for us, yeah, scalability comes from lots of participants being able to build things that are relevant to the problem they're solving. And our job as the data fabric, or the technological fabric that allows that to happen, is to build the fabric and then get out of the way, and then let the applications or services be built on top. And you know, and we have this conversation often with you know, customers within the same industry around competition. You know, how do we see ourselves if we were to build this data exchange, and it's going to be relevant for this particular project as well. How do you have competitors sit nicely next to each other? And our view is that you don't compete on the infrastructure layer. You compete on building services and applying your IP to the way in which you're extracting data, the transformations that you're using to turn that data into something that's meaningful. Don't try and compete. So I think, which is why this data exchange is of huge interest to us, because with that in place, the competition stops in terms of everyone trying to replicate doing the same thing. Because in our context, we only have a certain number of climate scientists, for example, on the planet. If everyone went out and tried to build these data exchanges, then they all had the climate scientists individually and sort of spread all over the place. We've got a big problem with scalability. So having that sort of fundamental layer, but being able to build on top of, is ultimately what this data exchange needs to be able to achieve.
Thanks, Steve. There's a question about permission of the data and the devices. So Gabi Seregra is asking, how did you obtain permissions to track each of the devices? Did each party, the employee or the delivery driver, need to consent?
I did. You can take that one.
Sure. So this is part of the reason we did anonymize the data, but this data for the experiment was given to us with permission from the parties that Marta listed up front. But in the fullness of time, a particular source of information and a participant would have full access to disclose what they want to whom they want using the distributed network.
Yeah, thanks for that. And look, there's a similar question or a follow-up question from Leonie Martin, who says, if there are QR codes or barcodes on transport vehicles, for example, can anyone scan those and gain the details attached, or would they need to use a login to get into the system?
It depends. It would really entirely depend on how you constructed the application that did that data capture. It could be either. And again, it's the design of the data exchange needs to account for each and every and all scenarios. And it came out with ResES, and it would come out with the other two presentations, I'm sure, is the absolute non-negotiable point around permissions and control. Access control, authorizations, permissions, and with that in place, then you can allow people to access with no login, no sign in. You could access without even having to have identify yourself if you don't want to, or you could have really tight controls over the way in which you access and into systems and use the data within it. But that's I think fundamentally it's a question of, you must control the data and allow the owner of the data to maintain control and ownership of their own IP and apply it in a way that they want to apply it.
Yeah, thanks, Steve. We got a question about the operating with distributed data from Chris Aitken. They say, thanks, insightful presentation. When you operate with distributed data, how do you handle changes in the underlying data structure within source systems? Could imagine this creates issues in production environments.
Yeah, great question. So I'm not the techie, not at all. So I'm going to give you the non-techie answer to that. Effectively, the way in which we have constructed the platform is, I mentioned provenance earlier. One of our fundamental core tenets around developing it was to be able to do that create a really strong provenance capability. Alongside that, and Adette showed you earlier the tree structure of the context, effectively within our solution, every single piece of data, every person, every model, basically any vector within the provenance of some form of data is created what we call a resource. That resource will be attached to everything. So for example, if you had a soil sensor, the soil sensor would be a resource. The data coming out of it would be a resource. If you maintained or calibrated that sensor, that would become a resource. So therefore, what happens in terms of change management, if there's an update to anything within the system, it just becomes another resource. It still ties back to the original data set, or it ties back to the original model. So what that allows us to do is that if, for example, we've got a particular transformation taking place and we've got a data source that we're using with a particular model, if that model updates or someone comes with a better model, we can reapply the model or the data to the new model without changing. So you actually create another flow or another branch of the data, but you've still got the original data sitting there. So again, it's really important to make sure that we have that provenance. It's not just the who owns it, where did it come from, it's the how was it used, what models were used, can I reuse that data, can I apply a different model, can I apply a new model to the data, can I apply new data to the model. Whichever way around you want to continue to create these trees and branches, but at any point in time, you can go back and poll or interrogate that. And that's how, when you see the demo, what that's doing is accessing that really rich source of contextual data to be able to really search on any way. You can slice and dice any way you want to, and then you can build any type of application on top of in any sort of formal mode to get the answer or solutions you're looking for.
Thanks, Steve. Look, there's only a couple more questions here on the chat. One of them, and I feel you already touched on this, but I'm not sure if you want to add anything else. Washington Gape has a question about if we could provide some additional examples of incentives to change behavior in this specific case. I know you have gone through it, but is there anything else that you would like to add in these regards?
I did. Have you got any?
Sure. I'm thinking it's a tricky one. I think it's also considering that. Sorry.
Sorry, go. No, it's got a delay. Sorry.
Go with it.
It's also considering that there are varying degrees of comfort with data sharing, so it's also not a one size fits all. So we did touch on that whole trust loop and just starting with sharing, and that might mean something different depending on where you are on that scale. So, and who you are depends on what value you would need to derive from the solution. So it's very complex, and there are many answers depending on who you are.
Yeah, well, I mean, I'd probably add to that. So something specific that was on one of those slides, and that's why we displayed it as looking at the supply chain or the value chain. If you're a winery, for example, so take Treasury and some of the discussions we had with them, optimizing their production runs when they're in harvest. So, for example, they need their silos, they need those things full to be able to push through as much as they can to utilize the equipment and push out as much end product as possible. So if they've got a difference between what's coming off the farm in terms of volume to what actually turns up at the winery, for example, and that's often due to forklift scales not being calibrated correctly, or if there's no scales on farm, the farmers are estimating. So it's no fault of anyone. It's just the fact that the data might be there might be less volume coming through, and they're much more likely to underestimate weight than overestimate weight. So when it gets to the actual production facility, you can imagine 100,000 truck movements. There's a lot of trucks lined up coming into some of these facilities. If the weight's significantly less, therefore they haven't scheduled enough going through their production process, then that can have significant economic impact on that particular harvest. So if you take that as an example, there's incentive from those types of organisations to start to look at how do we put sensors to be able to track and trace. Is it more viable to put some sort of weighing system on some of the larger properties to collect that information? So there's already opportunity costs and real costs in the supply chain that there is loss. So therefore, if we can start to capture those, then we start to think about how we might be able to use it for other purposes, such as a biosecurity track and trace. So if you say, for example, put a sensor on the bin and the bin had a much more accurate weight, you could then start to track that across borders. You can start taking out paper-based, dispatch dockets, because you can start digitizing them. So you're not just sort of using a new type of thing to get new data. You're actually starting to replace and incentivize the digitization of some of the existing manual processes as well.
And I think there's a big visibility angle as well. That is also something that did come through in the interviews, is that the growers often don't know who comes in and out of their farms, and providing a solution like this would give a lot of visibility to the movement in general.
Thanks, Steve and Odette. Look, there's a couple of questions that might not be just specific for this experiment, but I think it's worth to ask you guys what your thoughts are. So John McGurn asked a question about if there any of the experiments are looking at AI, ML to clean the data.
Certainly wasn't with us. But I wouldn't be surprised if somewhere in there that someone isn't running some sort of process. But ultimately, the role that would have in this type of process, again, it relies on the fact that the data is in a certain, able to be accessed, right permissions, all that sort of thing. So sort of going over some of the things we've already touched on, but certainly at scale, the data exchange will be right for machine learning processes to do all that work. And I think that's the exciting part, is once you get that sort of foundational sort of infrastructure in place, then it's open, so sort of almost an open slat, the free-for-all for innovators and creators to come in and start to look about how you make the actual process more and more efficient and capable of answering more and more questions at scale.
Thanks, Steve. And I'm conscious about the timing, but I really want to read a comment from Lucy Etheridge that she says, as a mixed farmer, using numerous data and assurance tech platforms, it seems to me that there needs to be more cross-industry collaboration. My meat management systems have things my wine grape system doesn't, and vice versa. More collaborative efforts will reduce the onerous task of learning multi-platforms for farmers too. We are time poor already. So I'm sure you want to provide a comment on this, but I thought, it was important that I acknowledge this comment because it is an important one.
Yeah, great comment, Lucy. And I think part of why a lot of people are here is that far too often and still today, farmers are the ones that typically have to pay for all of the fancy software and hardware and gadgets that are doing this, but very rarely are they the beneficiaries of the output. And I think what you're seeing here is how can we aggregate not just the data but also the systems. And Odette mentioned it earlier, one of the problems around comfort with process, we need to find ways to integrate into, as opposed to trying to sell another solution or another piece of software into the process, and also do it in a way that doesn't require a huge amount of re-education. There will be a component of that, I think, in the future, but ultimately, we need to make this entire data exchange that the supply chain, and I think when we focus heavily on change incentive, change of behaviour, it's time for the supply chain to start to invest in the solutions, and so that the farmers are ultimately the beneficiary without having to be the ones that carry the risk from both the capital and learning and adoption point of view. It has to be across the whole supply chain. And we didn't talk about it much, but a big part of what we focused on is the community aspect of all this. So for us, as Odette said, 3 of the things we found were social issues, not technical issues. And we knew that going in. We had a strong sense that this wasn't so much a technical problem, it was a social problem. And I think by being able to create the communities that wrap around the technology, that's probably even more important than the technology itself. I think we're at a stage with so much innovation that the technology is not going to be the problem here. It's going to be how do we design the systems and the change processes that are going to take place across government and business to allow these ecosystems to flourish. And ultimately, as I started, it has to be for the benefit of our farmers.
Sure. Thanks for commenting on that, and thanks, Lucy, for putting the comment on the chat. Look, it's 3:25. I just want to remind everyone that at 6:10 we have breakout rooms where people can actually have a discussion or have questions directly to the technology partners for each of the experiments. And with that, I really want to thanks everyone involved. With the biosecurity group, thanks Eratus, thanks Steve and Odette for an excellent presentation today, and thanks everyone for sharing knowledge and insights with the broader groups, and definitely thank you those who shared the data for the purpose of the experiment. And with that, I'm going to hang it back to Andy.
Thank you very much, Marta. Great work, team. Folks, let's go to Menti again, and we'll see what you think. We're going to ask the same set of questions again, but with regard to this particular demo, as you saw. Again, using menti.com, the same connection that you used before. If you can, here we go. People are starting to dive into it. What are 3 words that describe the demo you have just seen? If you have logged out of your phone or something like that, then the address is at the top there, www.menti.com, and use the code that you can see on the shared screen there, 66326486, will get you into the Menti screen. And then in your first set of fields, type in the 3 words that describe the demo you have just seen. And we can see the idea starting to emerge on the screen now. As people get to it, trust, innovative, exciting, keywords starting to emerge. And continuing to be very strong. So keep going, folks. We'll give you another 30 seconds or so for this particular exercise. Trust, innovative, and exciting. Visual, cool. Traceability, powerful. Innovative, really coming through as a strong theme, the central theme. Another 10 seconds, folks. Yeah, they're staying as the very strong themes. Innovative, exciting, trust, interesting, visual are the big ones. All right, let's move on to the next question then. And I think this use case could add value for the focus industry and governments, not at all to materially. Let's see where you land, folks. I think this use case could add value for the focus industry and governments. So very strong on both counts at the present time as the numbers start to increase. Very solidly sitting around the 2.8, 2.9 mark. Government's appearing to have the edge for the minute as the numbers go up. All right, just another 15 seconds to add your thoughts to this particular one. And the focus industry gets the pip of the post, back to level. 5 seconds to go. Level peg on 2.7. Good result. Let's move to the next question, please, Georgie. All right. To improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? So if you just type your thoughts into the text box there, you'll need to keep your answers pretty succinct. And if you just drop them in, we'll start to see them appear on the screen as we go. So to improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? So broader application, bin geolocators, a dashboard, mobile application, passive data capture, strong extension and training, all transportation, understanding the motivation to be involved, a standardized data sharing license, data security, accessibility. So mobile access again coming through as a theme. Improve standards. Take another 30 seconds, folks, to get your feedback on this. Strong government buy-in is another one. Dashboard, again, coming up as a theme. Dashboard simplicity. Government and sector intent. The comment here saying relying on human trackers and manual documentation would be problematic. All right, 10 more seconds, folks. Get your last ideas up on the screen there. Geolocation again. And dashboard reporting. All right, last 5 seconds to get your ideas in. Thank you to all the participants who are participating, contributing. Improved standards again came through. Data security, another theme. And ease of use is another theme. All right, mobile access again coming through as a strong theme. So some interesting themes that are replicated from the previous demonstration as well. All right, Georgie, let's move to the next question if we can, please. So how likely would you be to use this type of application if the Australian AgriFood Data Exchange made it available? So they're not applicable to me, through to almost definitely. How likely would you be to use this type of application if the Australian AgriFood Data Exchange made it available? So again, some very, very strong scores in the affirmative. Would likely adopt and almost definitely. No one's unlikely. A few not applicables, but mainly a big score. So we'll just do another 15 seconds on this. And so of the recipient numbers, we've got 13 and would likely adopt, 14 and almost definitely, and 11 and not applicable. So we're pushing the numbers at the high end, which is fabulous. All right, just in the interest of time, folks, we'll keep pressing on. So Georgie, if I can get the next question up, please. So which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? Which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? All right, all industries. Already a theme. All industries, all of them would benefit. All sectors, all transportation, all ag industries. Anything that is used to produce food. Any with a biosecurity exposure. It's a strong, strong theme coming through there. All right. Okay, folks, thank you very much for your contribution to that. Let's take a short break. Let's go to 3:50 p.m. for the afternoon tea break. We'll we'll see if we can get you back at that point. We'll start hard at that time. So if you can be back just before 3:50, and we'll get cracking with the next of the demonstrations. So feel free to turn your cameras off, step away from the screen, try and get yourself a little bit of a break, grab a cup of tea or a cup of coffee. We will see you back here at 3:50 p.m.
Okay, hello everybody, welcome back. I'm assuming everyone's had their coffee break and toilet break and are back in front of their computers now. Actually, I've got no idea because all I can see is me, which is a little bit disconcerting. So I hope there is someone else out there listening to this presentation, because it's going to be absolutely awesome. So my name's Chris Blanchard. I'm a professor of food science at Charles Sturt University, and very happy to be involved in this project, and very happy to be chairing the benchmarking project. It's which is fantastic, and it's good to see that Wes is here, because I'm going to be throwing to Wes in a moment. Thanks very much, Wes. So really pleased to be introducing our experiment today, and you know, not that I'm biased, but pretty sure this is going to be the best one that you've seen all day. It's really awesome, the work that Wes and his team have done in approaching this experiment. And the experiment we're going to be talking about next is the benchmarking experiment. And for me, I've got a real passion for this, because I've had a long association with the grains industry, and benchmarking is not a new thing. And I reckon that the very first farmers would have been benchmarking in some way, and that would have been looking over each other's fence, seeing, you know, why their plants are bigger than theirs. And that's really evolved, you know, probably more to the front bar of the pub, where producers might be comparing their yields and those kinds of things. But to me, you know, I see this really as an evolution, and I think we're just about to take that next step in our evolution and really apply good solid data behind benchmarking. And we've been trying to do that for some time, but of course benchmarking is a difficult process, because if you want to do it properly, you really need all the information. So the kind of processes that we've been using to date, yep, we're able to compare different farms, but you know, if one farm has a different soil type to another, or different rainfall, pretty hard to benchmark that. So I think the really exciting thing that we can do with the data that's available to us now, and potentially available to us in the future through the Australian AgriFood Data Exchange, is the ability to take all those pieces of data, bring them together, and to be able to undertake these benchmarking activities, where you can get a genuine and accurate idea of how you're performing, how your farm's performing versus your neighbours. And I think the thing that really excites me about this is not really about winning a competition. It's really about, well, based on that information, what can we do differently to improve the profitability and the sustainability of our farms? So, so to me, I see benchmarking as a really exciting activity for the change project process and practice change. So, and I think the sorts of things that Wes is going to be talking about today, you know, potentially is going to be delivering that. So I just want to firstly acknowledge all the work that a whole lot of people have done to make this experiment happen. And firstly, the working group, who all had some great input into defining the problem and assisting with gathering data for this experiment. And then we had a smaller working group, and thank you particularly to the GGA guys for their input in further refining the problem. And from my point of view, you know, it was very important to me that this was a farmer-driven activity, and I'm really grateful for the GGA guys to help define the problem, help source the vendor, and steer the vendor in the right direction. So we're really pleased to have Access Tech as our provider in this experiment, and Access Tech have brought to the experiment some wonderful technology, but also, from my point of view, a great attitude and a great understanding of what it takes to engage with farmers, and an understanding of how to actually engage with the farmers, so that they can engage in this process, so that we actually have data to work with. Because we always knew right from the start this was going to be the most difficult challenge, is to actually the farmer engagement part of things, and the data sharing. Thanks very much, of course, to the producers who agreed to share their data, and that's a big call. And I think the great thing with Access Tech, it makes it Access Tech, the approach that they take is they make it easy for the farmers to share their data, both technically, but also it's an easy decision for them, because pretty quickly the producer can see the benefit of sharing their data, and I think that's really helped in this process. So thanks to KPMG for the great job that they've done in supporting this activity. And really what we're here today to talk about is solving this problem, which is very much around benchmarking, and certainly farmers would are able to benefit from benchmarking activities, because it enables them to improve their performance, and allows them to compare their performance with other similar farmers. And if they can do that in a systematic way, then they can identify those parts of their farms which are underperforming. And if we can identify those parts of their system which are underperforming, then there's interventions that we can make to improve that. So ultimately, we'll end up with a much more productive system. And of course, as I mentioned, we've had benchmarking systems around for a long time, but they're labour intensive, they're boring, they're time consuming. And so what Wes and his team have done is come up with systems to take that labour out of it, make it less boring, and go straight to the fun stuff. And by doing that, using the data sources that are already available, Access Tech are able to provide an interface which very quickly farmers can benefit from and help them make management decisions. So we're really glad to have Access Tech as our providers, because they've got great technology. They've got already a really good working relationship with WA farmers, which has been really helpful. And they understand the needs of the growers. And I think the outcome of what we're going to hear from Access Tech today is really going to be a really useful way and groundbreaking way for us into the future to help farmers make the best decisions they possibly can. So I might now, so hopefully Wes is still here. So Wes, if you're still here, I might throw to you now to give a demonstration of our experiment around benchmarking the WA grains industry. Thanks, Wes.
Brilliant. Thanks, Chris. Thanks for the great intro. Very much appreciated. Yes, firstly, I'd like to acknowledge that I'm here in Noongar country in the southwest region of WA, and in particular the Wadjuk Noongar Budja here in the Swan River region. So I'll jump in, and thanks for the great intro, Chris. A little bit about me. So I grew up in a mixed farming operation in the Great Southern of WA. After working on the farm and for the neighbours for a period of time, moved to the city, did a bunch of interesting things around the place, and then founded Access Tech. So a little bit about Access Tech. We're basically an interdisciplinary team and working across data and devices. So a little bit about our grains benchmarking experiment. So we started with a broad list of data sets in terms of what we were working with. Those data sets consisted of producer data, CBH data, grower data, Sorry, I'm just having an issue here with the slides. There we go. And we also had data sets provided by GGA. So then one of the first activities we undertook in terms of this project was really to identify its voluntary nature. So the voluntary nature of this experiment was such that we needed to engage in producers, producer recruitment. Okay. Can the technical guys stop the slideshow occurring? Is that possible? So we undertook producer recruitment, and that was a really important piece of the process for this experiment, fundamentally because what was undertaken with it was that that in order to really identify some of the key benefits of the data exchange project, we needed to actually identify the value of voluntary engagement. So compliance is good and important, but in order to do that work, we needed to be able to actually understand that piece. So we undertook a process of doing exactly that. I'm sorry about these slides jumping around. They have a mind of their own. Thanks to GGA and DPIRT and the participating grower groups, in particular Esperance Zone Innovation Group, they were out on their own in terms of how advanced they were as a group and in terms of the work that was being undertaken. So from that point of producer recruitment, we then undertook a couple of key processes around data mapping. So then in terms of our data mapping, it was really about understanding that data, where it is, what shape and form is it in, where's it located, and what do we need to do with it in order to access it. From our experience, what we've found is that data is very much, has some real key technical challenges around it. It exists in inaccessible forms, it's locked away in separate platforms and databases. There's a lack of uniformity and standardization. There's nowhere to store it. There's real issues around data ownership, and we've sort of, a few people have touched on that, and there's even been some publicity around some of that. And there's no easy way to reuse that data or collaborate with it. And so what we did was we undertook a process of data onboarding in terms of those producers, really around doing some key data engineering work in order that we can take that data in the shape and form it's in, wherever that starting point is for growers, and bring that into a consolidated point. And within that, there's a few key underlying principles around that are important, and I want to just cover off on. So some of those principles are around, in terms of the voluntary nature of sharing data, the data is social. So there's a fundamental framework around data and its social nature. It requires control and trust and utility. And so really, these come to really the heart of fairness in terms of lowercase fair as an important piece of being able to meet the needs of producers. And we put this into a framework of control versus utility, where usually there's a trade-off, and each producer having a willingness to trade off one point for another, willing to trade off utility for control. And within this experiment, we have producers that sit right up the top here in terms of control and be willing to trade off utility in order to have control over their data, and others that are very happily and free in terms of sharing data, not because they don't want or need control, but partly because they feel they have sufficient control to meet their need and do what they need with it. And then it's about getting additional utility from it. So the view that we have and how we hear producers talking is really they need both. A key piece of addressing those challenges with the digitization of agricultural data is around data standards. And so this is a really fundamental piece in relation to making data fair in uppercase, and I'll get to that in a minute. But what we have here is a piece of work that we've been working on with SARDI and Uni Adelaide across a period of time. It's basically a practical utilization demonstration of the governance frameworks put forward by AgriFood, the Agricultural Research Federation. So well worth looking them up and being familiar with them and their work. And this is really an application of that. It's in final draft copy on our website. We'd love some feedback on it. The fundamental thing around it is really about trying to create a level of standardization in terms of naming conventions, nomenclature, units of measurement, and so on. And then we come to the fair data principles, which the standardization is an important part of. So in terms of our platform, in its basic design, and in terms of the practical implementation of it, we very much orient around these principles: findable, accessible, interoperable, and reusable. Interoperability being really fundamental when you're looking to exchange data, and in terms of generating value and demonstrating value, reusability is really critical. So the way we view that is that a piece of data work that has a value applied to it, often that value or return doesn't outweigh the investment or work required in order to digitize, in order to do that data work. One use of that data may not create sufficient ROI. Multiple uses generate multiple returns on investment. And it's that reusability that is really critical to generating that ROI that producers and other stakeholders need in order to be able to deliver the value from it that makes the business case stack up. So what does it look like after we've done some of that onboarding work? Well, as you can see, that this framework here of data and data mapping, and remembering in terms of that data map that we looked at previously, that data map was really oriented around data from IoT devices, it's data from deep Earth weather stations, it's data from soil tests within Decipher and other soil test platforms, it's data from within some cropping programs, and farm management platforms across multiple years where the farmers changed systems across that period of time, and some key cropping input records. Some of this started its life as filing cabinets of paper documents that one of our farmers got his old man to drop off at the office and said, oh yeah, here's my data. So it was some boxes from his filing cabinet. And so really that transformation work that we undertook in terms of being able to digitize and standardize that data before storing it and then creating that storage framework for the producer really was able to accelerate their own digitization within their own business. The fundamental first reuse of that data was for the producer. So they're then able to provide that analysis and insights internally within their own business as the very initial starting point. And all of these steps fit within an 8-pillar framework that we have on our website if you want to have a look at that. It's a sort of a useful concept in terms of how to piece it together. So then for this experiment, once we'd undertaken this data mapping and data ingestion and onboarding work, we then had standardized data within a structured data store. From there, we then undertook permissioned data sharing. And this was where the growers, or growers guided by one of our staff, were able to create assets within the platform that were granular level permissioning of shareable data, and then they were able to exchange that data into a separate data store. So this design here is a static exchange of data. Within our platform, we have models for dynamic exchange of data, and that has different use cases and applicability. For this particular experiment, we went with static exchange of data, fundamentally so that once the benchmark is created, it doesn't change whether a producer withdraws their permissioning of data or not. In a dynamic environment, a producer withdraws or adds more data, new producers come on board, or new data comes in mid-season, that benchmark changes dynamically. So within this framework, we exchange the data to the benchmarking data store. From there, we undertook the benchmarking work, which is really a series of processes and algorithms in order to take what was a variety of data sets. Some, even though they were standardized, had come from different sources. So the source was still standardized in line with its representative point, but there was key variety in that data that meant that there was harmonization steps required. And so we're able to conduct those harmonization steps and then conduct the benchmarking work. From there, in the principle of quid pro quo, something for something, we were able to transact that data back to the individual producers. So the data that came back to the producers was that benchmark data set, completely de-identified, but it was the data set that they could then, within the safety and comfort of their own data store and their own reporting environment, conduct their own analysis of their data points in relation to the benchmark data points. And so then from there, they're able to review some of what that actually looked like for them within that analysis. What I'd like to do at this point is actually jump across to a screen share. And so if you're able to follow along in the screen share window, and then I'll share this and provide a bit of demo. Okay. All right, so I hope you're able to see that okay. So basically what we're looking at here is within the Access Stream platform, we have individual projects. Projects are those particular data stores. And I'd like to acknowledge one particular producer that we're working with who's kindly provided his data for us to view within this piece of work within today's session. So John Sanderson from Sanderson Farms, he's at Grass Patch, sort of northwest of Esperance, and also has a property up at Varley. He's there with his wife Desiree and little daughter Sailor, who's a bit older than that, and a cheeky little monkey, but she's awesome. So within this project and within this data set, we're actually working with data from approximately 30 different farms. But the way that grain growing in WA and across the country has translated is that there's been a consolidation of ownership and management of those properties, such that those 30-odd individual and separate farms shrink down quite quickly into similar and consistent management across a number of farms where maybe those farms are neighbouring. And so we've treated them as a fairly homogenized data set, or the producer themselves, the grower themselves, manage them as a consolidated group. So one of our first steps was really to run some analysis on some of the data that we're working with in terms of some key locations, and then really be able to, working with some data provided by DPIRD, we're able to put some key analysis points around that, and be able to take that data that was there within a very extensive data set provided by DPIRD and actually run some key analyses across it in order to be able to use that within our benchmarking experiment. So that became some initial analysis work within the mapping structure, and then we pushed it into the data store. So we'll jump in here to Sanderson Farms. And so this is some key data within Sanderson Farms, and within the Access Stream platform, they're able to then view and manage that data. The structure of data is of this tabular data is in types and streams, where type is basically a make and model, and the stream is the individual deployment. So within that, we're able to dive down into whether it's data from a management platform, data from CSBP, as you can see here, it's seeding data, fertilizer input data, and so on. Some of this started as you can see, started as text files, some of it started as paper documents or Word documents, some of it started as data within databases. It's all been transformed and standardized and fundamentally made reusable. So within that, if we then jump into a particular data set, we can see here, this is some CVH load data, and we're able to dive down and look at the attributes and metadata attached to that particular data set at a fairly granular level. Within this data framework, we're then able to do some interesting analysis work for the producer. So the producer is able to look at some devices, they're able to do some work around soil test analysis and micronutrient analysis and so on within some sufficiently sophisticated analytical tools. They're able to look at things like their grain delivery. So we saw a structure of data in relation to that grain delivery, and then we're able to do some drill down with it. And within this data set is some really rich and interesting stuff. So we're able to jump into, say, wheat, and we're able to look at maybe protein levels within wheat and look at trends across time. We can compare farm versus farm and paddock versus paddock and year versus year, and look at trends across time in terms of protein levels within wheat. Or we could switch across to canola, and then maybe we have a look at, say, oil content as an example, and be able to look at trends across time and conduct that first reuse of data. So at this point, we're already starting to add value to the producer for their participation in the project, but to participation in a data project, and they're able to really extract some value from that. So that meets that first requirement where there's something coming back to them around that. We're then able to create a convergence of data. So within the platform, we have all of this very broad set of data that's come together into one storage framework. It's still lots of structure in that data, and then we're able to create that convergence. So if we have a look here, I might just have a quick look at two particular data sets here. So this is some soil data. We're able to add in or extract out particular data attributes and filter them in or filter them out. And we're able to either use a count or a date period in order to create a really consolidated granular control over that data. And we're able to create emergence of data between two otherwise disparate data sets within the platform. And so from there, what we've done is we've created a data set from within Sanderson Farms. So here we're within an individual producer data store. This is real producer data, and they're getting real value from it. We're able to create this data convergence with, at this point, it's 31 different streams that go to make up our benchmarking set. And we're able to converge them, filtered by attributes with granular level input. And then we're able to create a token around them. So our community framework is how we would do this work if we were running it dynamically. In a static environment, we're pushing it to an Exchange framework. or what we've called an exchange framework. We could set that to expire if we wanted. We're able to create a specific token in order to do that work. So from there, we've done all of that data ingestion work, we've done all the transformation, we've stored the data, we've given the farmer use of data, and then we're able to create a granular level control over the ability to share that data. From there, we're then able to change hats and put our benchmarkers hat on. So you remember from my graphic before where we were able to, in fact, I can, if you've still got the slides open, I don't know if you can see multiple little windows with it, but you can see here we're then exchanging the data into the benchmarking. So here we've got incoming data. We're able to select that data. And from that data, we're able then to preview it in terms of the individual attributes within it. So this is a particular setup and structure of that data. We're able to link it into a particular project. So in this case, it's come into the benchmarking data store, and we're able to then identify those streams and go about importing them and confirming that exchange of data. So at that point, a copy of the data is taken from within the particular private data store of that grower and exchanged with granular level permissioning into a completely separate and distinct data store that belongs to the benchmarker on this occasion. And that process we basically just repeated for each grower and facilitated them and assisted them in being able to create that sharing capability. Now, remembering that while possession is 9/10 of the law, the other 10th is needing to be taken care of in terms of data sharing agreements. And so as part of this work, the producers, all the participating producers had a data sharing agreement. In another context, we may well have an embedded agreement process where they're able to sign off on that data sharing from within the platform. So then we move into the data storing piece, and we're able to then conduct our benchmarking work. So this is the benchmarking data store. And as you can see in here, we've got a whole series of data sets that we're working with that have come in from individual producers. And then we also have data that's created into a benchmarking work. Now, how do we undertake that? We undertook that through a series of algorithms. So these algorithms, the way we look at it is that data should be reusable, and so should algorithms, either for free or for a clip of the ticket or a consumption basis or something like that. But the idea that you can host and use an algorithm and use that algorithm more than once, we think is really important. And so we sort of peel back a layer on that and expose these calculations and capabilities within the platform. So as you can see, some of it is about standardizing values. So soil sample chemistry is an example where we have data sets coming from different soil sampling labs. And while the attributes of those data sets have been standardized on ingestion, they aren't yet harmonized in terms of the ability to use them in a benchmarking framework. So we simply run an algorithm around that. That then creates another harmonized data stream that then we can use in order to create our values. So as an example, a water use. So this is a building block for water use efficiency. So if we wanted to run this algorithm, so as you can see, it's a reasonably extensive little piece of work. We're able to run that algorithm and create some of these outputs from it and preview it and see that it is the data that we're looking at and expecting. So this is actually running an algorithm on the multiple data points that have already been exchanged into the data store, and we're running this algorithm across the top of them. It could be a little bit slow. screen sharing. There we go. So we come out with a particular count. So this is using a CSIRO model for calculating water use and therefore water use efficiency. From there, we're able to push that into the data store. And again, through that similar workflow, actually create a new data set that is that processed data. So that value-added data that is then similarly reusable. So from there, we're able to put that together. And then what we've done is we've then transacted it back. And so we've basically transacted it back to each individual producer. And then I'm going to jump straight back into Sanderson Farms and show you a little bit of what that actually looks like once that data transacts back into those grower data stores. So here we've got high, low, medium values from our benchmark data set, and we've got the actuals from Sanderson Farms for their farm for this time period. So we've run the data back to 2016. So we've covered a good chunk of time, and this is real data. This is and thanks again to John for his openness in sharing this. This is real farm data. This is real yield outputs. It's not granular at a paddock level. It's at a farm level, but it's still real stuff. And so what we're looking at here is being able to analyze this across a whole series of different fundamental soil attributes based on some of those deeper data sets we were looking at before. We're able to see comparisons of how John in this dark blue purple line here is performing against benchmarks and averages across the entire group based on this attribute. So no longer are we just limited to analyzing based on rainfall zone and going, oh, the only comparison point is according to rainfall zone. Actually, there's a lot more attributes that we can be working with and looking at. So if we wanted to, say, have a look at port zone as an example, and we can work through multiple commodities. So we can see here, John was the leader within barley for this period of time. And then the emergence of someone else from within the data set as the leader, providing that max value. John's actually dropped down to average and then below average for a bit. And then by the time 2021 comes along, he's back up as the leader within that piece of work. So let's have a look at what happened there within wheat. So he's similarly started at the top, moved to average. 2019 looks like it for him it was a bit of a tough season. 2020, bit of a tough season, and then 2021 up above average in what was a strong lift up where others had an even stronger lift up. And so there's some key rainfall related stuff that translates to. If we have a look at that same thing in terms of water use efficiency, so what were we looking at there? Port zone and wheat. So let's have a look at port zone and wheat. So we can see here that the metric looks different because we're assessing a different benchmark framework, but we're looking here according to port zone, and we're able to see that John, in terms of water use efficiency across those earlier years, has actually been average. So right in the middle, just doing a good job, going about his work, dropping down a little bit there in terms of 2019 and 2020, but picking up again into average water use efficiency, or just above average for 2021. So if we wanted to drill down a little bit further around maybe some of why that's occurring, we're then able to look at key things around maybe some soil metrics. So if we wanted to have a look at pH as an example and see what that's going to do to our metric, let's just go back to wheat. Okay, so we can see there that based on that John's pH movement one of the drivers for him was actually an increase in acidification. So this is pH on a scale where acidification is lower numbers and base values are higher. So the target range is really in that 6.5 to 7.5. That's the real sort of optimum growing level. Here we can see an acidification that's occurred for John that he's been able to turn around in 2020, 2021, and that's actually one of the key drivers that's pushed him back up to be the leader within this benchmarking group. Some other things that have taken place for John is some decisions around nitrogen application. So we can see here that his nitrogen levels, and I'll come back to this in a second, but his nitrogen levels were quite low. And so timing of a soil test record is it'll occur before the growing season. So the soil test we're looking at here is before the growing season. It really is a predictor of how that season's going to go and what nutrients need to be applied. So he's relatively low in-soil nitrogen at the beginning of the season, picked up in 2020. So if we went back and looked at John's fertilizer records, we'll probably find an increase in FERT application during that period and another one again, so that he's come into 2021 with a higher level and bang on average level of nitrogen in the soil before the growing season. And nitrogen being a key driver behind plant growth. So there's some quite neat stuff in there in terms of what we're looking at and what we're able to do with it in terms of that data and within that framework of taking one set of data, sending it off, having it processed, worked on, de-identified, aggregated, and then brought back to being able to be analysed within that data store. I'm going to just jump out of the screen sharing here for a minute and just dive back into the presentation. So we've covered off on those bits in there. We've worked through the experimentation. It's all good. So then we come back to a little bit of what did it actually translate into in terms of when we were working with producers, what was the feedback, and where does this sort of go from here? So some of the key feedback that we had was very much about grower engagement. And grower engagement needs time, it needs trust. Probably one of the key pieces is it's social and needs to be worked within existing social structures. There's some key benefits around the work that we did. Firstly, the work that meant that they were able to do their own internal analysis within their business was really valuable. But then the translation of that into being able to do some of their own work against those benchmark data sets. So one of the things we found was that for producers like John, his ability to actually run his own analysis within his own platform was really important and useful for him to get that verification or cross-reference point against the group, to then compare himself against the group, meant that he could just sort of reference check or value check some decisions he was making about fertilizer application in particular, or pesticides or herbicides or fungicides or whatever the work he's doing, the particular applicants and nutrients and so on, whether he's deciding to pursue a more solid biological framework rather than chemical, or whatever those decision points he's making are, he's able to reference it just against the group and go, okay, against this group, I'll cross these metrics, how do I compare? And what that meant, what that sort of translates to for him is that his time input is reduced in creating that analysis. He's able to use that benchmarking work multiple times. So rather than looking at it as a PDF or paper copy and it going back on the shelf, he's actually able to work within this data-driven framework. He's able to run internal analysis around paddocks and farms and varieties and so on, and then he's able to run it against the group and understand his own performance relative to his peers. So within that, the time required for him to be able to make decisions is actually creating a greater level of self-sufficiency. So rather than doing all of that work with an agronomist or an advisor, he's able to do a big chunk of it more himself. He's not going to be getting rid of his agronomist or advisor anytime soon, but in those peak seasons when those agronomists and advisors have absolute demand on their time, he's actually able to progress himself and make a whole bunch of decisions and be able to make those decisions more accurately himself. What does that translate to in terms of key values? So it could be a simple decision like a fertilizer application where, because he's been able to run some analysis himself and value check against the group of peers, he's maybe able to not need the 20% buffer that he may otherwise apply. He may actually be able to scale that back and be much more targeted with his nutrient application and therefore more efficient. So efficiency being particularly important when your input costs are 2 to 3 times what they were last season, as this growing season's looking like due to a whole series of global forces. So for John, you know, that translates into cost savings and more accuracy. His ability to run some yield potential calculations to really understand what that translates to based on rainfall, and then apply nutrients accordingly. The yield impact may also be a quality impact where he's actually able to push that up for himself from maybe APW to ASW, which is going to deliver maybe $80 a tonne additional as a premiumization on that same commodity, on the same use of land, on the same inputs, but actually through an increase in protein levels, be able to push it up a grade and therefore get a premium on that product, all the way through to some key decisions like, so say in 2014, he had an issue with powdery mildew, which is a fungus that can occur on wheat crops. He made a decision to not apply some fungicides because it was looking like it may or may not be an issue. If he was able to even see and understand what was happening with that season more broadly, he potentially could have changed his decision. And so for him, the difference was an application of that fungicide might have cost him $20 a hectare, but the loss of yield as that season progressed and its end of season, it played out. He had some real issues with it. As that season progresses, that translates into, 600 kilos, 800 kilos loss of yield. That then translates into maybe $160 or $200 a hectare on an average wheat price of $300 a tonne. So, if you're talking yield in a product like canola that's $1,000 a tonne at the moment, those small increases can deliver real value. So there's real translation for it in terms of how that comes together, but it's about multiple layers of benefit in terms of what the producer can do with it and how they can use it. So a little bit of what do we, from this experiment, what do we think, how are we sort of seeing the world and how do we think it'll play out? I guess there's a few key principles around it. So governance being really, really important. Things like, so for a broader exchange rollout and framework, fair data principles. We're throwing our little bit to into the industry in terms of the agriculture data standards that we've put together on those particular metrics. We see that has potential to expand, and we see other things happening like collaboraculture in vineyards with in South Australia, some really neat piece of work. The ability to address issues around producer trust and producer ownership. There's some key pieces of work happening in that space, and we think it's important to be able to harmonise with that, whether that's AgriFood, whether that's the National Farmers Federation Farm Data Working Group, who are really looking at a certification model to build on top of their existing farm data code, some work Food Agility are doing around best practice. There's need for a harmonization across all of those things for data governance. Producer engagement, I guess there's really a whole bunch of learnings from stuff that we covered off on earlier. Data is social, so engaging with producers, the easiest way to do it is through existing social structures and build collaborations and projects and really build out those use cases, but where producers are able to engage with that. To understand what digitization work is required in order for producers to participate, appreciate the time cost required and demonstrate value for them on multiple levels, and provide some knowledge for them as part of that engagement point. And then we're seeing a whole series of value-driven use cases, time savings, input cost savings, productivity growth, quality improvements, some of what we've covered, simplifying compliance or biosecurity reporting, as some of the other guys have talked about, market access through data transparency, some of that traceability capabilities, but also layering in key elements that are here or coming around sustainability and greenhouse gas reporting and the greenhouse gas emission reporting, ESG and natural capital accounting. So how do we see some of these more advanced uses occurring? So some future applications is really within an interconnected supply chain that facilitates transaction of data moving forwards. The ability to have landscape or district or region scale projects, I think is quite significant, and that's a bunch of work that we've been doing within Access Stream, is building out the capability to do that, and this framework of sustainability and natural capital accounting. And so, as one application around that, we've been doing some work with the Global Farm Metric out of the UK, which is really a harmonized framework for being able to ascertain some key value propositions around natural capital accounting and sustainability reporting. Keep an eye out for one of the Rural Woman of the Year Award finalists who's got a project around exactly this. And some other data science applications, whether it's around some optimization modeling, and there's projects happening with DPERD and liming optimization, or it's projects happening around really maximizing the understanding of yield and soil structure and nutrient points and soil chemistry and biology in order to understand and identify yield components. So that's sort of some key future pieces with it all. For us, that translates into a platform that's really part of what we're building out, and this is a bit of where our platform is at now and where we're seeing it expand to, and we're really excited about the opportunity of collaborating with a project like Ag Data Exchange and being able to support that with technology, support it in multiple points in terms of assisting growers, connecting to it, assisting with the facilitation of the exchange, facilitating that interconnectedness within and around data. So a few key thank yous. So thanks to all of our key producers that participated in the project, Grower Group Alliance for their input and support, the grower groups that we worked with, so Esperance Zone Innovation Grower Group, and some of the others that participated, so Stirling's Coast and Facey, and Madfig, Sepwa, that were engaged in the process, support from DPERD, Grain Growers, Plan Farm, the crew at WA Farmers, and of course KPMG and Charles Sturt, and our collaborators on the Australian Data Standards Guide in terms of SARDI and Uni Adelaide. So Rakesh and Rhiannon, if you're tuned in, thank you. Thanks for your input on that and support and working collaboratively as we have, and it's great to get a first version out and into the arena. Excellent. That's me.
Here's me back. Great presentation, Wes, and I think the really good news is there are people out there because there's some questions coming, so which is very reassuring. So I might throw a couple of these questions to you, and you'll be able to probably interpret them better than me, but let me give it a go. So we had a question come in pretty early in your presentation, so it's maybe more a little bit generic, but the question is, do you really see control and utility as explicit/zero-sum trade-offs? What about all of the privacy preserving data sciences work? Something that comes to mind specifically is the open-minded work. So I guess the question...
I think that's is that a reference to a particular program that's taking place? I'm
not sure, but I guess it's, you know, the essence of that, from my understanding, is really, you know, is it a fair trade-off? So I guess the contribution of what the farmers contributing versus the contribution of what, for example, your system is.
Well, hopefully that question's actually been able to be answered, because fundamentally within the platform, we're actually delivering both. So the ideal is to actually deliver both control and utility. And I think that one of those earlier slides was really around trying to highlight that traditionally the options are trading off control and utility, and where one gives up one's data, only to find that they don't then have in order to get utility, but they then don't have control. So really the fundamental behind the platform is being able to deliver both control and utility. And that's both in terms of some technical stuff, but also a philosophical approach with it. So I think hopefully that's come through in the presentation and sort of a question.
I think it has. Yeah, I think it has. But I think it was worth highlighting, because I think you know, as we've discussed, Wes, that benefit back to growers is such an important thing. So, you know, it has to be a win-win. And, you know, I think that's the key to the success of what you're doing, which is great. I've got another question here. Again, a little bit of a more generic one. So our definitions of sharing and exchange, are they the same? We seem to be using the two terms interchangeably. So sharing and exchange, what's the difference, Wes?
Sure. So I guess there's, so in terms of the frameworks we work with, some allow for, and we like to use collaboration more so than sharing, where really key producers or participants are able to collaborate with data around a project that may or may not result in exchange. So I guess there's a few different models and understandings or articulations of exchange. One might be the physical transfer, so what we described as a static transfer of data, where a block of data physically transacts or transfers from one ownership to another. Whereas a sharing or a collaboration may well occur without any movement of data, but say within our communities framework, actually being able to create a collaboration framework that doesn't require data to move anywhere. It's simply permissioning access and consumption. So for us, separating out consumption of data from the ingestion and storage of data is a key piece of understanding how you can achieve some of those things.
Yeah, and I like your focus on the collaboration, you know, which again comes back to that win-win. So I think there's certainly nuances in those terms, sharing and exchange, but and they possibly mean different things to different people. So thanks for that, Wes. I've got another.
Maybe we can put that on the list for the governance framework for the exchange working groups, to actually create a set of common understandings around these things, so that actually for an industry we're able to use the same words to describe the same thing.
Excellent. We're going to have to wrap it up now, Wes, but there are opportunity for people to ask some more questions later. But I just wanted to finish up with a comment from Shane. Well done presenting while those slides kept jumping around at the start. So nothing like a bit of technology to get the adrenaline going. So so that was good. So so thanks very much, Wes, for that presentation. You know, I'm so excited about where this is going to lead, and you know, I think you guys are doing a fantastic job, and thanks very much for all the hard work that you've done here. So so we might move now to the next presentation.
Here we go. Thank you very much, Chris, and thank you very much, Wes. You definitely get the Unflappable Award of the day. We'll move into the Menti questions on this particular demonstration. So, Georgie, if we can get the Menti presentation up, here we go. So, folks, for those of you who are needing to reconnect with Menti, use the QR code or www.menti.com and the 8-digit code you see at the bottom there. I'd love as many people as possible to participate if you can on these Me questions. The data that we are able to take from them following will be all the richer for your participation. So, Georgie, if we can get the first question up. So the QR code's there, or www.menti.com. And that web address and the number, the code is at the top of each slide as we go through, folks. So if you're late in joining, that's how you jump in. So from the presentation that you just saw Wes take us through, what are 3 words that describe the demo you have just seen? So if you go into that first question and then the 3 fields there, what are the 3 words that describe the demo you have just seen? And I'd encourage as many people online as possible to dive into Menti and give us your thoughts. So practical is the winning theme coming through at the present time. Awesome, exciting, groundbreaking, transformational, innovative, benchmarks, farmer focus. Keep the thoughts coming, folks. Innovative still the primary theme, with practical and exciting also there. Keen to see if we can get a few more thoughts coming up. Again, innovative, data-driven. So the 3 words that describe the demo you've just seen. I'll give you another 30 seconds. Useful, innovative, and practical. Dominating the screen at the moment. Last 10 seconds. All right. Thank you, folks, for your participation. Georgie, let's move to question 2. I think this use case could add value for the focus industry and governments. So not at all on the left, materially on the right. Okay, focus industry, looks like it's got 3 out of 3. Governments somewhere in the 2/3 range. So keep your thoughts coming in, folks. I think this use case could add value for the focus industry or for governments. Not at all on the left and materially on the right. All right, we'll leave this open for another 15 seconds. All righty. Thank you, folks, for your participation. Georgie, question number 3, please. To improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? So if you just enter your free text into the box that is available on your screen, and you'll need to keep your notes pretty succinct. But to improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? Mobile app comes up again. Better spatial visualization. Simple, simple, simple. Clean data, how to connect other data. UX, digital connectivity. Keep it simple. One-on-one. Instructional to user. Dashboard again. An economic scenario tool exploring how governments can use. Mobile app again as a theme. So exploring how governments can use this for resource policy making and enabling exports. More and more data. Mobile app, keeping it simple. Digital connectivity. So I'll give you another 15 seconds, folks, just to enter your final thoughts on this. Dashboard again coming up as a strong theme. Mobile app. All right, folks, just add your final thoughts. Clean and simple user dashboard. Simplicity coming through again is a very strong theme for this. All right, Georgie, let's move to the next question, please. How likely would you be to use this type of application if the Australian AgriFood Data Exchange made it available? So from not applicable to me through to almost definitely. Let us know how likely you would be to use this type of application if the Australian AgriFood Data Exchange made it available. And once again, folks, the more of you that we can get responding to this, the richer the data set will be that we can draw upon. So how likely would you be to use this type of application if made available? And we'll give you another 30 seconds to respond. So final 5 seconds. Okay, again, thank you to respondees. All right, let's go for the final question, please. Which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? So which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? Again, use the free text box to type your answer in. Aquaculture, grains, any. All applicable to many commodities. All, very strong theme, all. So any other thoughts, folks? All benchmarking, all industries. Horticulture, viticulture. General consensus, I think that broad application is there. Most all industries and ag sectors. Another 15 minutes to finish off here. Fisheries, any, all, strong theme. Once again emerging from this. Thank you, folks. All right, folks, we'll move off Menti now and we'll introduce the final presentation for the day, and the workstream chair, who is the General Manager of the Fisheries Research and Development Corporation, Jojo. I'll hand over to you to take us through the final demonstration.
Thanks. Yeah, last but not least, and maybe I would challenge Chris with regards to him saying that his was the best. I'll say maybe we left the best for last, right? As you may have seen, there's a lot of cross applicability with regards to all the three experiments that you've seen previously. This one's no different as well. But we did have to make a choice with regards to seafood, because if we're such a heterogeneous sector, we ended up choosing lobster, as you can see. The question is, why lobster? Because if you think about it, it sort of represents what we're trying to achieve here with regards to Australian agri-food products, right? We have markets that want information. We're a premium supplier. We're pest and disease free. With food safety, clean, green, and we're also trying to access new markets, etc. Right, and in doing so, we're not going to be eating more or producing more, right? What we want to do with these kinds of experiments is like find some way to make the production cost less or make the producer more money, right? In doing so, sorry, I should be moving the slides. Sorry. Okay. Yeah, in doing so, we have a challenge where in our industry, we want to pick something that is quite hard but not too impossible. We picked something where it involved hundreds of fishes, some post-harvest processes like Generative Fishermen's Co-op and Indian Ocean rock lobster, and then we've got a management agency, which is WA. Taking those into account, we wanted to address a pain point, which is about the delay in data reconciliation that happens because of non-digitalized processes that are still in place with regards to processor returns, and also about the inefficiencies when there are when fishes go out to fish. Processors need to be able to know when they're coming back so that they can send the right truck, the proper truck, etc. Right now, processors have to call around to say, hey, who's going fishing, who's coming back when, and then they have to arrange transportation logistics in that way. And the other bit is, of course, we're talking about traceability, and to get that, there needs to be ability for end-to-end data exchange between multiple endpoints. To do that, we wanted to showcase quota accounting data, which is related to compliance as well. We want to take the catch data to showcase catch data from fishers, from the department, and then compare with the processors data to do quota accounting, and then deliver the pre-fishing nomination back to them. And in this working group, we've got quite a few participants. The primary one where we're working closely together with FFAC DC, we've got the Western Rock Lobster Council, which represents the rock lobster fishers. We've got the Generative Fishermen's Co-op, which is the largest processor of Western rock lobster. We've got Indian Ocean rock lobster, and last but not least, we've got the WA management agency. And then as a larger working group that help us guide this process includes, we've got Australian Eggs, FIAL, New South Wales DPI, Charles Sturt University, MLA, CSIRO, AgVig, and APCO. Then what we did was we wanted to take the economic efficiency for processes and try to derive that by using a data exchange and accelerate the reconciliation of catch, and also the ability for the supply chain participants to streamline the compliance activity. At the end of the day, right, what we did was we took those challenges and went out and got the IBM and Telstra team to help solve this problem that we have. And this is what they came up with. So I will hand over to Tiz and Mark.
Thanks a lot, Jojo. I'll just take over and share my screen. Hopefully you should be able to see my screen now. Hi, everyone. It's a pleasure to be here. Thanks for the great intro, Jojo. It's a real privilege to be involved in this program, and I'd just like to say a big congratulations to all the other teams on the great work that you've presented. Obviously, we're at the end of the afternoon, but hopefully you've had a second wind and everyone's ready for our demo as well. Apologies in advance if there's a bit of background noise in classic form. There's an overzealous gardener that's just started trimming away a couple of doors down, so apologies for that. So my name is Mark Kaysen. I'm an associate partner in IBM Garage, working across product and ventures. And also in this presentation, you'll hear from my colleague Tiz, who's been the lead from the Telstra side as well. So obviously, two organizations that I've just mentioned there aren't necessarily known in this space as working together. So I just wanted to introduce where this partnership has actually come from with the AgriFood Data Exchange and our participation. So this is a strategic investment from both Telstra and IBM, where we've really come together with two different solutions. And we think that the power of putting them together could provide something really meaningful for the AgriFood Data Exchange. The capabilities that we've brought, we want to allow operational, transactional, and analytical data to be combined and generate valuable insights. And so the two solutions that I'm referring to, one is Telstra Data Hub. And the way to think about that is essentially its mission statement is to make data sharing as simple as making a phone call, right? Something that's going to be critical if we can have success with the AgriFood Data Exchange. So that's really an application layer, and that's already in existence in Australia and in other use cases. And also IBM Blockchain Transparent Supply, or BTS, which is essentially the decentralized permission sharing via the blockchain, which a number of IBM solutions are built on top of, both in Australia and globally as well. So the key point here is that these two solutions are both, production grade, highly scalable operational systems that are already in existence, as I said, across different use cases. But we've brought them together into the architecture that you see on the right-hand side here. I'm not going to step through that in any great detail, but what we will do is we'll step through a few key areas of this architecture that we leveraged for this specific experiment. What I just encourage all of the, audience to do as we go through this is to keep in mind that what we're demonstrating here is based upon the data that we were provided specifically for this lobster experiment. But the key principle from both Telstra and IBM's side, and also what I know is very aligned with the AgriFood Data Exchange, is that what we've built and what we'll demonstrate is a highly flexible mechanism that can span across different commodities or product types, but also across different supply chains as well. So as we go through the demonstrations, for your respective industry or your supply chain of focus, you can keep in mind how this could be scalable for you. So first of all, I just want to give a bit of a shout out to all the work that's gone into this. It's been a lot of fun. We've done it's actually over quite a bit over 12 weeks, and during that time we've had extremely privileged access to all of the participants. Jojo mentioned them. This is a summary of the work that was done, but I think the bigger message here is that the collaboration was exceptional from everyone involved. I know from both the Telstra and IBM side, we really enjoyed it and really appreciated that. And it really does set a good, starting point for actually doing an AgriFood Data Exchange. It was really encouraging to see the openness and collaboration that the different organisations were willing to offer. So, effectively, what we've done here is we've put together a number of personas. Sorry for the slide skipping there. We've put together a number of personas for the different people that were involved in this experiment. Now, obviously, these are fictitious characters, but coming from the real organizations. I won't go through this in detail, but it's important because as we go through the demonstrations, you'll see different presentations from the perspective of different users, right? So we've got a fisher, a processor, an industry body in WRLC, a regulator in DPIRD, and then a compliance officer. So as I said before, these are kind of roles or personas that exist in other industries and other supply chains. So as we present from their perspectives, you can apply the lens that's relevant for you. Once we had them personas, we really started to dig into the supply chain. Appreciate you can't really see what's on the screen here, but what went into creating this was a lot of hard work really across a number of dimensions. So looking at what's the compliance that exists in the supply chain, what's the flow of goods, what's the data that's currently captured, what does that data currently look like? And we pulled all of that together. This is indicative. There's a load of other pieces of work and artifacts that we created. And all of them came together into a synthesized, cohesive document, which essentially is a current state supply chain map that you can see here. Obviously, this can't be viewed on screen here. I appreciate that, but this is just to really show the process we've had to go through to get that kind of deep understanding of how this supply chain currently operates. And so we mapped that across a number of different kind of swim lanes, as you can see here. And then we started to think about, okay, well, based upon what we know now, how can we leverage our supply chain data exchange solution to address the key frictions that we'd identified, and also capitalize on the opportunities that we thought existed as well. So the first thing to focus on from our perspective is the data layer and the data management services of our solution. The reason for that is that, if you think to yourself, well, why hasn't this been done already? Why doesn't this already exist? It always comes back to data in my experience. And also that's something that, I've had great discussions with our broader team and also other representatives in the broader program of work. And that's because the data that's currently in existence, it's not necessarily shared, but it's also not standardized. It's in disparate systems. Those systems don't necessarily offer interoperability. The right incentive mechanisms might not be there. And so what we first started to dig into was, okay, what data do we have access to, and what within our data layer of our solution do we need to use in order to make this data shareable across this supply chain that we're focusing on. So this is an indicative view, oversimplified, of course, of what that looks like. But if you just start at the top, you can see that there are 3 different data sources that we essentially were given access to. And that was from DPIRD, being a regulator, from IORL as a processor, and GFC as a processor as well. That data comes into our system. So, see this as almost a double click of of one of the data layer components. And what we then had to do is cleanse those different data sources. We had to transform them into something that could then be stitched together. We had to anonymize and aggregate the data to ensure that no sensitive or commercial information was to be shared. And we needed to then package it up so that it could actually be shared along the different supply chain participants. That's what that event XDS layer is. And XDS stands for exchangeable data set. So that's that's the term we use for our platform as to when something is in the form it needs to be able to be shared along the supply chain in a permissioned fashion. It's an exchangeable data set. Until it's gone through that process I just described, it's not an exchangeable data set. It's just a data set. When you've got an exchangeable data set, what's also then really powerful is that you can attach additional exchangeable data sets to it. They can be related data sets. As an example, on the left, you can see additional vessel information or integrated marine observing system information for seafood. For other industries, it would be other related exchangeable data sets. Or it can be related analytical data sets. Again, in seafood, it would be stock assessments or maybe weather or BOM information. but also for other industries, it can be whatever those data sets are. So you can see how you start to layer up and kind of connect together these exchangeable data sets to be able to create meaningful value. What then needs to happen, though, is there needs to be a level of data standardization, permissioning, and decentralized storage. And that's to make sure that obviously it's standardized, so we're all talking the same language here. It's permissioned. We're all comfortable with the access we're giving from our data to others. And it's stored in a decentralized way such that it removes the need to have trust in that data. And that's what the blockchain transparent supply offers in terms of storing it on the blockchain, but in permissioned fashion. And then you get to the kind of bottom layer, which is what we did was, then in terms of that standardization, we turned all of the data into EPCIS GS1 event data. So that it's then understood, globally. I know there are, GS1 representatives on the call today, but also that then it can be even stretched across other supply chain participants, but also other industries, right? So really trying to transition the data. So what that actually looks like, again, an oversimplified form here, starting from left to right, we started with, disconnected private and public data sets from multiple sources. They were in the form of Excel sheets or ERP systems, databases, even open data sources. And so as a team, what we had to do was combine those into multiple relational databases and relational schemas, which is the second image. But that was still a number of different databases and schemas, so it's still relatively complex. What we then did is transition it into one common schema with that simple XDS, exchangeable data set format that I mentioned. And then we map those exchangeable data sets to the widely adopted EPCIS GS1 events. And so basically what that resulted in is the data that we started with on the far left, it actually became standardized for consistency and interoperability across stakeholders and industries, but also is supported by controls that ensure data owners have the control they need. And so this is what would essentially need to happen to make the AgriFood data exchange a reality. We just demoing it here in one very specific use case. So once we had that data ingestion and transformation complete, and we'll give you some demonstrations now, that then gave us the foundations to be able to build that application layer. So there are 4 demonstrations that we'll go through. One of them is the actual permission data sharing. So what does that look like? How do you go and provide permission, and who do you provide it to, and why, I guess. The second is quota accounting. So we'll show how we leverage the platform and build an application layer on top that could digitize the quota accounting process. Again, that's specific for seafood, but as you view this, you can think of it more broadly as a capacity management type tool. It's essentially a scalable offering there. The third demo will be logistics planning. So how did we digitize that? And then finally, what brings that all together is a demonstration on traceability. And so I'll hand over to Tiz now to take us through the first 3 demonstrations, and then I'll pick up and finish off with traceability and the remaining content we have to get through.
Thanks, Mark. I'll just share my screen. And hopefully that has come through.
Yeah.
So what we're doing now, great. So what we're doing now is we're logging into the supply chain data exchange powered by Telstra and IBM. And we're logging in as our Fisher John. And what we're demonstrating here is the permissioning of data that John actually owns in the supply chain data exchange. So as you can see here, John is a producer, he's an owner of data. Because we've done the event exchangeable data sets, they can be grouped up and they actually have ownership now. And so John is the owner of this data. And this, as many of the previous presenters have also said in their demonstrations too is that it's important that it builds trust, that you know that you own your data and that you've got control over permissioning of your data. So here's some of the event data has actually been grouped together, packaged together. So we've got some data that John's going to share for regulatory purposes, data that John owns that he's going to share for processing purposes to make that easier. There's also data that John owns that are his trip records as he goes out and he does his captures. And he could choose to share those, but we'll just demonstrate the regulatory and processor data because they're actually going to feature as part of the applications that we're going to demonstrate later on. So in the official regulatory, John's going to share his data and he's picking to share with WA DPIRD, who's our regulator here. And you can see there that it's been shared. There are some default sharing that's already been set up, which I forgot to mention earlier, just through participation in the supply chain. John's also going to share data with his processor, and he's picking processor A, who's a processor he's working with, and that's completed. Now, the sharing just needs to be set up at the beginning as John onboards into the supply chain data exchange, or if he wants to change the permissions and the sharing. So for example, say one season John changes his processor and therefore he doesn't want to share with processor A anymore, he may choose to share with processor B. So we're actually going to now run along through a supply chain journey, through the Western Rock Gloucester supply chain journey, to see how the supply chain data exchange actually can provide benefits to all the stakeholders, and more specifically, John and processor. So our fisher John and his crew, they're standing around at the dock and they're going to plan their next trip. Their next fishing trip. So the last time they did a fishing trip was about 3 days ago. It's towards the end of the season and they want to know where they're going to head out. But before they head out on their next trip, John really wants to check his quota balance. What is the quota balance? So a quota is basically an entitlement that is set for each zone in the Western Rock Lobster fishery, and it's for sustainable management of the fishery. And as Mark said before, you can think of a quota entitlement, it's an annual production entitlement, but in this case, for other industries, you might think of it as a capacity limit for production, and it might be a capacity limit that's introduced due to downstream supply chain constraints such as warehousing or processing limitation, or it could actually be a constraint due to the actual facility that produces. So previously, John would have to wait up to 2 weeks to get his quota balance updated potentially, and because he did his last trip 3 days ago, he may not have the quota balance updated if he didn't have his data electronically submitted through the supply chain data exchange. 95% of fishers, including John, do currently send their net weight of catch post-landing electronically through to DPIRD, and DPIRD's done a great job of incentivising fishers to actually do this electronically. However, the processor also has to provide net weight of their catch post-landing, and they don't do this electronically. There's no mechanism for them to be able to submit this data electronically. The data is actually in their system, so they've got to manually fill out forms and they've got to physically mail the data to DPIRD. So DPIRD as well aren't able to electronically reconcile the quota balance. And to reconcile the quota balance, effectively they take the highest of the net weight from either the fisher and the processor, and that is the usage that then goes against the quota entitlement. So what we're going to show now is how, by electronically sharing data through the supply chain data exchange, we actually reduce the quota balance that John's able to view from 2 weeks down to something that's a little bit more real time. But additionally, we're going to show some other opportunities, and it actually contributes to incentivising John to use the quota accounting application more and to actually record his data electronically. So we're now going to go into the quota accounting application demo, and again, think of it as like a capacity management application for other industries. So we log in as John, And John can see data that's owned by him and also that's been shared to him. And here we can see that John's got a quota entitlement, and the quota entitlement is made up of temporary units and usual units. Usual units are his entitlement, and temporary units are units that may have been he bought at the start of the season or he obtained at the start of the season from another license holder. And against that entitlement, you can see the usage. And we've got here the dark purple area, which is basically what's already been reconciled by DPIRD. However, what we've actually managed to do now as well is that because we've got data shared through by the processor on the net weight electronically, and we've got John's or net weight as well, we can actually estimate what the quota usage will be from the last trip or last two trips that John actually did. So we're showing in the light shaded area an estimated usage of his quota. That's not reconciled yet. However, John expects, because it's all electronically provided in the supply chain data exchange, that DPIRD will actually reconcile that fairly quickly within 24 hours. So that'll get updated in real time. So no more waiting for 2 weeks for John to have his quota balance reconciled. So he's fairly confident that he can still have do a few trips. And as you can see, we can also collate average catch per trip. And it also allows John to have an estimate of the trips remaining. So he's got about 9 trips to go. John can also have a look at how his catch has been going along the season and compare that to the catch in the previous season. And that can actually inform his future catches. So, potentially it will increase because towards December, January last season, it actually did increase. Furthermore, because we've got the additional data, as Mark mentioned before, from such as weather data or ocean conditions type data, we can actually combine that data with the season catches and inform John on potentially what influences his catch and why it might have increased in certain months or not. The other thing that is of value to John here, so we've not just got a quota accounting application, but we're giving John a lot more information on how to plan his trips. So we've got the insights because we've also combined his catches, but he can also see individual trip records that have actually contributed to his quota usage. And he can actually record things like cost and his revenue electronically, but also have that shared through from his processor. And you can see here that we've got a view of weight and revenue from his processor as well as from back of boat sales that he's made. And he's also recorded some costs. The good thing about this is that we can actually then combine that again with other data, and we've got even more information now for John to actually be able to plan his trips with and actually decide where he's going to go for it to maximise his profit. Just a quick view, we've got the processes actually showing how he's actually managed his revenues. He shared the processes shared the data with John, and John can actually view that detail. And we can also then provide a view of, well, what was my revenue per kilogram and my cost per kilogram, and what's my profit, and what trip actually gave me the best. Maybe I can have a look at the methods I used or the conditions that impacted that and make better decisions. So now we're going to log in as Ben from DPIRD. And Ben can also view the data and the season's usage for the zone. So he can actually have a look at how all the fishers have used are tracking towards the quota allocation for that zone. And he can sort by the license holder as well to manage to decide on whether there's any concerns there and if he has to do some extra efforts to manage the fishery. DPIRD already have this data in their systems. The idea, though, is that we can also provide another view to them if they want to use this view. But additionally, you saw before when we did the permissioning, John actually owns some trip records, and he can actually share de-identified data as well with Western Rock Lobster. So we've logged in as Western Rock Lobster Council here. And Western Rock Lobster Council can get the de-identified data. So you can see the managed fishery license identifiers being removed. And Western Rock Lobster Council can basically use this data so they can do industry benchmarks. And we saw before, the use of data to provide benchmarks. It's also applicable within the Western Rock Lobster industry, where John the Fisher now gets an industry benchmark also in his insights. And he might use that benchmark to have a look at how his performance is against the industry benchmark and make decisions on maybe changing methods or locations or other things that influence his catch and improve. For example, his costs may be over compared to the industry benchmarks. What can he do to improve those costs? The other thing too is that we can share these values without the identifier to both DPIRD and Western Rock Lobster Council, and they can actually do research into maximum economic yield and other research that might inform better sustainability and management of the fishery. So John's now got a lot of information, a lot of insights. He's really excited about the information he's got. He can really decide on how he's going to plan his next trips. He also heard that in a week's time, there's going to be some whale sightings data provided in Supply Chain Data Exchange, so he can actually check to see where the whales are and make sure he doesn't go and fish where the whales are actually located. So with all this, he's planned where he's going to fish for his next trip. He now has to fill in his pre-fishing information and submit that to DPIRD, and the pre-fishing information will have where he's going to actually fish, and he provides a block number, not the exact location, and where he's going to return to, and when he's going to return to with his catch. He submits that pre-fishing information to the data exchange, and DPIRD accesses this. Now John is out on his boat, and they've gone to where they've decided they're going to do fishing, and they examine their pots and they sort the catch, and they put their undersized catch back, and they reset pots. They record the block location and the soak time, and they separate their catch into the back of boat sails, and those for the processing. You can see the tag containers there that have separated the catch. And whilst he's doing all this, John's really, really pleased that he no longer has his processor ringing him and finding out where are you going to be landing, when are you going to be landing, and so that I can plan my logistics and for you and for all the other fishers, because John has now submitted the pre-fishing information into the Supply Chain Data Exchange. He's not only shared that with his regulator, but as you saw before, he's actually shared it with his processor as well. So the processor is actually getting this information from the data exchange as John updates his pre-fishing information. But John is also updating his pre-landing information. This is also an obligation that he's got to update. And with the pre-landing information, he's adding things like, this is this is the size of my catch, the number of containers that I've got. And again, the benefit here is the processor's getting this updated information as well. So the process is not having to ring around to get updated information, and they're actually getting the latest information for logistics planning. And additional benefit to John is that he can add bait orders, and he knows now that his process is getting those bait orders, and he's going to meet him with the actual bait order that he requires. So what we're going to do now is move to the landing dock, and because the process has now got this information from the Supply Chain Data Exchange and no longer has to do this manual ring around, he's got a few people there waiting for John's arrival and for the arrivals of the other fishers. And he's really excited because this information is actually getting updated on like an airport arrivals type board. So more precise planning and more precise activation. The data is actually getting submitted at least 30 minutes prior to landing, because Telstra's got great connectivity 30 minutes out from the landing port, which is terrific. And And so the right size trucks and also more precise supply orders are provided. Now we're going to go into the logistics planning tool. We're going to log in as Lily, the processor, and we're going to select several ports to see what the data looks like and select the date. So this will actually show us how a processor can actually view this airport arrivals board that the fishers, that they're now getting from the pre-fishing and pre-landing information that's been exchanged with them through the supply chain data exchange. Noting previously, this only went to the DPIRD system and processors couldn't see this data at all. So we can see here that you've got that sorted in time of arrival amongst ports. And the reason for the multiple selection is that you might want to plan logistics for a number of locations, or you might want to plan logistics for a processing plant that's actually serving a number of locations. And logistics planning is something that's applicable to other industries. So not just seeing the airport arrivals board here, but you can actually go down and see the totals as well. And as the pre-landing information gets updated as well, we're getting containers and of course bait orders as well. So again, as I said before, just allows for more precise logistics planning and activation as well. There might be changes though, because John might decide that, and other fishers might decide, actually, we need to change our location. It might be because of weather conditions. It might be because they're closer to a different port. So they change the location. And this is actually the alerted to the processor, and the processor doesn't, can understand that, some changes have been made and they can adjust the logistics planning accordingly. There's a future opportunity here that if you're not in front of this sort of screen or an airport arrivals board, that we can actually send SMS or email notifications based on the changes. There's also value to John in having a view of the port arrivals, of having the port arrivals information, because now that we've got more boats coming in at Geraldton, we can also notify John that there's potential port congestion at Geraldton Port. And so John can now slow down, and in slowing down, he can actually save on fuel costs. So here we've got benefits not only for the processor, but we've also got benefits for John, and we've actually got, the landing logistics are operating more efficiently for both processor and the fishers. So post-landing, John can fill out his net weight, which is required by DPIRD. And as we said before, that net weight post-landing actually goes into being reconciled for the quota accounting balance. And DPIRD can access this because it's gone through to the supply chain data exchange. There's an opportunity here also that John actually submits his fuel costs and his bait costs and other costs such as labour, and he can view these, as we saw before, in the quota accounting application. And the de-identified updated data is also accessed by Western Rock Lobster Council for industry benchmark and performance metrics. So the appropriate transport has been arranged by the processor, and as the data exchange because the data exchange has enabled the more efficient logistics planning, and the process is effectively, potentially saving on fuel costs and other costs due to this better logistics planning. So the trucks are here, the tagged crates are loaded onto the trucks, they end up going to the processor. And then we're going over to the processing plant. And at the processing plant is actually our processors are quite modern, and they actually weigh and grade the lobsters along the conveyor belt, and the data is automatically captured into their systems now. However, before, where they had to fill in manual forms, now they can actually get the data. The data in their system is actually electronically shared through this into the supply chain data exchange, and the processors actually permission this data through to the Fisher and DPIRD and Western Rock Lobster Council, the relevant parties that they want to permission that data to. So John's actually receiving confirmation of his catch value from his processor automatically. Again, you saw that we could provide a quota balance estimate straight away, even though Depot will likely reconcile it electronically within 24 hours. But John also knows he's going to get paid soon, so that's pretty important to him as well. And savings for the processor, time and effort, and also errors in data. No more ringing around to the fishers to understand where they're going to be landing, and no more filling out manual paper forms and sending that physically to Depot for compliance. That's saving a lot of time and effort for the processor as well. And now I'm going to hand over to Mark, because the lobsters orders are ready to go and be distributed to the purchasers from the processor. So Mark, over to you.
Thanks a lot, Tez. So hopefully you can all see through the demonstration there for logistics planning how those kind of the automation, the digitization, and the operational efficiencies that can be unlocked. We brought it to life through this, particular supply chain with the data we had access to. But that kind of capability, already exists, and I know from IBM's side we've done that with other in other engagements globally as well. So that's something that can be brought into this this platform as an offering, and will be moving forward. If we continue now on the journey, obviously all of that data that's now been captured, it creates possibilities downstream that don't currently exist. So as an example, when the processor then is looking to do the trade or to on-sell that particular product, the purchaser can now request access to that information. So in this example, a purchaser could, at the point of purchase or as part of an agreement, could ask for permission upstream to know what where the product has come from, what journey has it been on, what information exists for this particular product. The processor is now in a position to be able to offer that, and because they're part of the supply chain data exchange, you'd be able to trace the end-to-end journey for the product, but you'd also be able to see all of that rich associated documentation, certification, and metadata that has been captured, assuming that permissions have obviously been granted, and everyone can have confidence that it's all securely and immutably stored within the solution. So what I'll now show is the traceability demonstration. So you can see here, if we search for a product, let's say obviously Western Rock Lobster, we're then able to say, okay, well, for that product, what level of granularity do we want to search? Now, the data that we've had access to was obviously at a certain granularity, and that's what we'll now show. But it's important to keep in mind that the actual solution here can accept data at any granularity, right the way down to product level, to pallet, to lot, container, and so on. So the kind of hierarchy and granularity of data is something that it can be ingested very easily into this platform. What we'll do now is you can look at, okay, well, what kind of date range do we want to search by, and then over what time period? So what activity and what time period? So if we just pick some the random date for the data we had, we can then look to find that data. And so the system will then search, and it can see all of, in this instance, all the records that appear that meet our criteria. We can select one of them, and we can trace that that particular data set. And so if we now trace, what you can see is essentially the journey, the supply chain view, and you can look at a product view of that as well. So you can see, right the way back to source, and you can see how that product has branched off along the supply chain at the various different points and participants. If you go back to the supply chain view, you can click deeper into the data as well and see what makes up that particular event. So as an example, if we look at the fisher, like the inception, you can click into that and you can see the date, the time, the event type, the additional data set that exists. And you can also importantly see documentation. So here we've got, the fishing license, a return form. These are sample documents. But what this shows is the power to be able to attach documents, relevant documents along the supply chain, and be able to share them in a permissioned manner. Obviously, we know today in this supply chain and many others, paper-based systems do still exist, and the way that the information that's stored within those documents is shared along the supply chain can be quite manual. Obviously, it's not going to be automated overnight. And so what the platform is really showing here is the ability to go on that journey, whereby the documents as they exist today, which, yes, is paper-based and often manually created, can be uploaded so that they can then start to be traded and shared digitally. But it's important to remember that moving forward, this kind of system, there's no reason why it couldn't actually automatically generate a lot of the documentation, because if the data inputs are already within the system, then the creation of those documents and the sharing of those documents could all be done digitally, which could obviously save a lot of efficiency. So create a lot of efficiency, should I say. So here's an example of one of the documents, and you can go into it and see, you know, as an example, the fishing license. We've used, you know, anonymized or fictitious data. And I also am aware that's not necessarily exactly what a commercial fishing license looks like. So it's just indicative, right, to say that you can upload documents and you can see the additional data that has been added. In this instance, it's just showing a very simple view. But you could imagine how a document could have a number of properties or a number of additional data sets that have been added to it along that journey. And you can see who it's being shared with as well, or who you're currently sharing it with. Another example would be the processor return form. So again, as I mentioned, something that's been manually created, but actually could be uploaded digitally and then shared and attached to products. So that's at the start of the the kind of supply chain, and you're really then looking at, I guess, producer information. You can pick anywhere along this supply chain view to look at the data that exists. But if we look at the actual product view now, so if what I just showed was more, producer and that level of information, if you want to look at the actual product level view, you can go and see the creation of that data. So here, what we call it commissioning, or should I say GS1? So the commissioning, like when did an individual product actually be caught or registered for the first time? And what journey has it taken? So you can see here it was commissioned, and then it was shipped, and then it arrived. And you can see the record numbers that have been captured, the entities, or in this instance, the boats, where it was going from and where it was going to. What you can then also do is you can go into the documents view as well. So if let's assume at this instance, I'm, deepered looking at this, so I have a more holistic view, assuming I've been given permissions or access. You can then filter by different document categories or different document types. And you can see this could be a central location to be able to store or access all of the documentation that's needed for important workflows or processes. What can also happen, though, is the data can be updated or edited, and everyone can be made aware of what's happened and be alerted to that. So you can see here how we can edit a document. We can change who we want to share it with, or add who we want to share it with. We can add additional metadata to it, and that can then alert others as well. So the collaboration can happen across documentation or across event information. As long as it's permissioned, without the need for people to, physically be actually together, working together, the system can enable that. So that's the example of, one document that can also be done on other documents as well. So, you can edit any of the documents in there, assuming you grant edit permissions, right? There's also the ability to restrict it to something so it can't be edited or added to. So that's just a bit of an overview of the kind of documents area, and something that's hopefully coming through quite a bit. I know that I'm mentioning it a lot, but the permissioning is really important. And so this is where within the user's view, I can see who I'm actually sharing, who I've got as users, and then who are the system users. So what are the organizations I'm sharing data with, And within those organizations, who specifically am I sharing data with? And so that's what you can see on this screen here. And for each of those users, you can edit their permission access, or you could actually delete their permission access. And so there's a way to be able to manage, I guess, your exposure and who you're sharing data with and for what purposes are you sharing that data can all be managed within the system here. And what I've just kind of talked through in terms of traceability, you know, this can exist in any, as I said, on any supply chain for any given product. The functionality already exists. It's already in use globally. But we went through it in quite a linear, I guess, quite a linear process just to for the purposes of a demonstration. But actually what can also happen is that data can be captured at different points in the supply chain at different times and then retrospectively stitched together. So, you know, as an example, it doesn't have to be that end-to-end traceability. Again, when we think about how we're going to create this as a reality, it is going to be, one of the challenges is going to be getting everyone within a given supply chain to actually participate. But actually this solution can still work and provide value, even if there are parts of the supply chain where people don't necessarily onboard straight away, because wherever the data is captured, it's able to be stitched together retrospectively. Just something to keep in mind. So that's the traceability demonstration based on the data we were given. And obviously this now puts a purchaser in a position to have great confidence in the product and be able to see everything about that product that they've been given access to. There is also the ability to have more rich data sets added. So as an example, with the logistics planning that Tiz talked us through as a demonstration, there is already the ability to be able to provide temperature data or other quality control information and attach it to those, you know, the events, so that you can have that assurance and guarantee of what's happened to that product and what state it's been in as it's moved along the supply chain to you. So there's endless possibilities in terms of how much data can be added once you have the foundational traceability capability in place. So that kind of brings an end to the demonstrations. That was showing what's possible based on the data set that we had access to. But I think it's really important to call out that there are many opportunities for what a supply chain data exchange could provide, above and beyond what we've demonstrated, and also the great work that others have demonstrated as well. And what we've done is captured a lot of that in what we call a future state map, which talks about all the things that could be made possible if additional data sets were used. And within the working group, we went, you know, there are already a number that have been validated as highly desirable by the participants in our experiment. And I thought I'd just call out 5 here, which actually are already possible today with the technology that IBM and Telstra has. And so one of them is automated logistics planning with the use of AI and machine learning. I know that was a question someone asked earlier on in the day. So there is the ability already to know the exact number and size of trucks and be able to optimize transport routes. And then in this instance for seafood, you could predict bait orders and other supply chain requirements. Individual product image scanning. I know there's great work happening across different organizations, some of which I know are on this call, where you're able to use image recognition to be able to individually identify products or species. So that data could then be added to the traceability demonstration that we gave. There's the ability to predict fishing plans and optimize fishing routes as well, and provide visualizations so that you equip producers with tools that can leverage their existing data sets to enhance their future fishing activities. And then there's also the ability to create efficiencies within the approvals for exploitation space as well. So the ability to capture additional quality control information from transportation, such as, you know, health certificates and export documents, so that certain key data points can be automatically calculated, such as expected handling times or arrival times. And then finally, one of the things that we've had great discussion about is the ability to automate approvals with smart contracts. So in the seafood example, one instance of that could be quota transfers or quota acquittal, balance updates. But I think just more broadly, given the platform that we've presented is based upon permissioned blockchain, the ability to leverage smart contracts to automate exactly that, agreements and contracts, basically. The opportunities are enormous. So I think that that's something for us all to keep in mind as we continue on this program of work. So with that, that brings our presentation and demonstration to an end. So thanks all for your time, and I guess we move into Q&A.
Thanks, Mark and Tiz. Great presentation. Can everyone hear me? All right, let's go to question and answer. Conscious of the time, we've got 6 minutes. So there's 3 questions about the blockchain. So what I'll do is there's a question about, are you using smart contracts, and what blockchain are you using, from John? And I'm going to pair that with another question from Nate to say, super general question here. If there's a specific reason that a blockchain was used versus something different like a hash graph, thinking mostly about speed, performance, environmental impact, etc., would be great to understand the way trade-off decisions about these factors were made. So I might throw that to you, Mark, about what kind of blockchain it is, why this blockchain was used, and whether we're using smart contracts.
Yeah, sure. Thanks, Jojo. Look, I think very, very honestly, my first response would be that it's often the word blockchain or the use of blockchain can spark lots of great conversation, right? But I think what we've presented there is based upon a blockchain platform, and that's blockchain transparent supply. Other people on the call might be more familiar with IBM Food Trust, which is the kind of global system solution that IBM has. That sits on top of IBM blockchain transparent supply, right? So there's Hyperledger Fabric, which is basically fundamentally sits underneath it all. One use of blockchain transparent supply is IBM Food Trust. Another use of it could be the Supply Chain Data Exchange. We brought that together because the traceability experience that IBM has across the different commodities and supply chains that we've used IBM Food Trust, all of those learnings are built into the blockchain transparent supply solution. And so that's, to answer the question, that's why we used it, and that's why we think when pairing that with the Telstra Data Hub, it really does create additional power and impact, because the Telstra Data Hub is creating those exchangeable data sets that can be provided in applications, of which we've just demonstrated 3 of the applications, 2 of them, quota accounting and logistics planning. So I think that answers the question. The last bit that I guess I probably didn't answer is why was it used?
Why
the reason,
blockchain versus the graph?
Yeah, so I mean, the why is effectively that it comes down to the value of blockchain in general, right? Whether it's us using it or others. What's going to be key here is the ability to create permission data sharing across organizations who currently don't necessarily talk to each other, and the immutability of that data is then going to be really important. The ability to create permission data sharing, and also the future opportunities of being able to create smart contracts to further automate. So I would say, how much value are we getting for blockchain right now in this demonstration? You could call that small. How much value can you get from blockchain over the medium to long term? If you start to leverage its full capabilities, then it can become an extra large, right? So I think that's how I would frame it. But it's not, it's not a must necessarily, but I think it makes sense.
All right, thanks, Mark. Next question was, would you be able to share more details on how data is being de-identified? This is from Thierry. Is it just the removal of personal identifier, or are there more processing done? Is that you, Tiz, or Mark? Who wants to take this?
I can probably respond to that. Yeah, in terms of de-identifying data, so if you, I'm trying to see if I can explain it without getting too technical, but one way of viewing it, for example, might be where you've got one row of the data actually contains the identifiers there, and another row of the data, the identifiers have been removed. So any sensitive data, that might actually mean that you can identify, a fisher or a license number or a boat number or something like that. Think of that as being a separate row where that's been removed. And so when you actually share the de-identified data, you're sharing the rows that don't have that identifier, you're just sharing values. So that's the mechanism, and it's all part of having the exchangeable data sets and the standardized data. So another way of viewing it, for example, is that you don't share the columns that actually have the identified data. You're only sharing the columns of the actual values. I hope that's helped to explain it. So in terms of what is identity, that's really part of the industry to decide this is sensitive identifier type data that we don't want to share, and the values that aren't sensitive, we agree on what those are. So you actually would tag those columns or those rows to actually identify that. And I didn't show it in the permissioning, but for example, the fisher with the trip records could have shared de-identified trip records and made that selection. I hope that's answered that, and I know we're coming up to time, so I'll be quiet.
Yeah, thanks, Des. Philip, you've got a question about data control and Professor Wiseman's work, and then there's a couple about the scanned document and about trialing with industry going. Like, you could stay on for another 10 minutes where we have the breakout session. Would love to dive deeper into those questions if you wouldn't mind staying on, and I will hand back to Andy, 6 o'clock sharp.
Thank you, Jojo. And well done, team. You had me at Rock Lobster, quite frankly. So, Georgie, let's chuck the Mentimeter questions up there for this particular demonstration. And once again, folks, there's the QR code and the Menti. Georgie, I think we've played this game before, so we'll jump straight into the first question. So for the 128 of you online, what are the 3 words that describe the demo you have just seen? So in your Menti, in the 3 fields that you have there, 1 word each, if you can drop in, what are the 3 words that describe the demo you have just seen? And so for those of you, it's just coming up now. So again, if you're going, where is Menti? There is the code up the top there, www.menti.com, and use the code 66326486. Okay, the 3 words that describe the demo you have just seen: practical, beneficial, future-focused, innovative, extensive, creative. Thorough, inspiring, extensive, dynamic, innovative. So some themes starting to develop: creative, innovative, extensive, practical. All right, we'll give you 30 more seconds, folks. Keep them coming. The 3 words that describe the demo you've just seen. Alrighty, okay, 10 more seconds. Extensive, innovative, practical. The big ones coming through there. So well done to the team. All right, Georgie, second question, please. So I think this use case could add value for the focus industry and or governments, not at all on the left to materially on the right. I think this use case could add value for the focus industry or governments. Alrighty. So once again, I'll ask as many as possible to enter the data. It helps us get a really rich harvest later on. to be able to use this information going forward. So really strong for the focus industry and very strong for governments by the look as well. We'll go another 20 seconds on this one. And people's information still going in, still very strong in both. And 10 seconds. All right, wonderful. Thank you, folks. Third question, please, Georgie. To improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? So please enter your information in the open text field on your phone and hit enter. Just a succinct number of words. To improve and enhance the benefits or user experience of this type of application, what would you recommend be considered? And drop that text in now. Mobile app. How strange for that to come up. Inclusion of other data and add more insights. Visualization of data. User experience. Machine learning. Simplicity, data exchange, more species. And spatial application, GIS spatial maps. Theme developing there. Data needs to be able to leverage. There's a mobile app coming through again. Data needs to be able to leverage by third parties. Inclusion of biometrics ID. A different interface for different end users. Keep them coming. 15 more seconds on this one. Simplicity again coming through as a theme. Common across all demonstrations today. Mobile app simplicity. And in the other three so far, dashboard has come up as consistent themes. Visualization in this one is strong. 5 more seconds. Dashboards. Power of suggestion. No. Simple, coming through as a big common theme here. Data governance. Big data. Okay, Georgie, if we can, let's go to question number 4. Thank you, folks. How likely would you be to use this type of application if the Australian AgriFood Data Exchange made it available? From not applicable to me to almost definitely. So how likely would you be to use this type of application if made available? And we'll just leave it a few more seconds to see if we can get a bit more response coming in now. Almost definitely and would likely adopt. Very strong. 15 more seconds. And 5 more seconds. Thank you, folks, for participating, and we'll move to the final question now. Which other agriculture, food and fibre industries do you think would get greatest benefit from this type of application? So what other type of industries do you think would get greatest benefit from this type of application? Once again, if you can type in to your free text field, red meat, beef, all, anything with transport, logistics and processing, all, any seafood. Keep them coming, folks. Green life, yeah, strong theme around all. Grains, any fishery, horticulture, even beyond agri-food and fibre. Plant produce, protein chain. All, yeah, plant produce, cotton. Well, very strong theme about universal applicability. Other big fisheries, abalone, etc., seafood, any. All right, I think we get the picture. Well done. Thank you, everybody, for participating, and well done to the team. I'm now going to hand over to Piers just to take us through a quick debrief and next steps. Over.
Terrific. That's great. Thank you. Thanks, Andy, and thank you very much for all of the demonstrations. My name is Piers Hogarth-Scott. I'm a partner at KPMG. I'm supporting the PMO role of the Australian AgriFood Data Exchange. Just before I talk about what the next steps are in the project, I'm just going to spend about 5 minutes on this, and then we'll move into the 4 separate breakout rooms for people who'd like to go and engage in direct discussion with each of the technology partners. But just some observations on some of the key themes that we've seen today. I think it's important to understand that the demos or the demonstrations that we've seen represent different methods and approaches for exchanging data. And the reason that we've undertaken those experiments with 4 different technology partners is really to help inform the design and the business case of the Australian Agri-Food Data Exchange. There's also been really positive feedback in the ideation sessions in terms of the potential uptake and adoption of the use cases. I don't think I saw anybody say that they wouldn't adopt one of the use cases, and in the majority, there seemed to be pretty strong desire to adopt them should they become available in the Australian Agri-Food Data Exchange. And by way of extension, the applicability of those use cases across the whole of the Australian agri-food sector. I mean, they were selected from a long list of about 25 or 30 in the first instances through broad-ranging consultation with the sector as 4 potential use cases that had broad applicability right across the sector. Another common theme that came out is enabling infrastructure. We heard a number of people refer to enabling infrastructure, and I think it's really important that people appreciate that is the intention of the Australian Agri-Food Data Exchange, to be enabling infrastructure to really help turbocharge and enable the sector to move forward and drive that competitiveness. And what do we mean by enabling infrastructure? Well, think of it perhaps like an index of available data sources that private users are willing to make available, and public foundational data sets that are available. Another key theme, building trust. Trust by the user and the data provider. And that's something that's actually been addressed in the data governance work stream of the overall program of work. So let me take you through what the next steps are, and it's worthwhile, I guess, just recapping the overall program of work, because what we're currently focused on is the box with the dots around it. Prior to that, it was about crystallising the vision for the Australian Agri-Food Data Exchange, which was done in conjunction with a very broad range of agri-food stakeholders. And then obviously moving into identifying the core use cases and assembling a collaboration. I mean, this is a remarkable collaborative project involving a broad range of the agri-food sector. And then in terms of what you see there as phase 2 and phase 3, that's really what we're in right now. So that is where we've been setting about to understand the viability and the feasibility through the development of the experiments and obviously manifesting in demo day today. And that's one of the key inputs that's being used to inform the business case. One of many inputs that's been informed that is an input to informing the business case, along with other components around what the operating model might look like, what the data governance might look like. And these are all ultimately, as I say, designed to help inform the business case. So the immediate deliverable that we're leading up to is a business case to stand up the Australian Agri-Food Data Exchange that will then manifest itself as a funding application into the future phases and the deployment of a minimal viable product and moving into operations beyond that. So in terms of the I guess, bringing that back home and the more immediate next steps, what you can see on the screen now is the accelerated timeframe. Originally, we were looking at a December delivery timeframe for the business case, but that's been accelerated largely because of the desire in the market to move forward with such an initiative. And again, as you can see, the business case gets delivered in September. But prior to that, where we are right now, and you can see the vertical line of demo day, and the data governance work stream that's currently in flight, and that again that comes back to the whole trust equation, and also the operating model considerations that go into the business case as well. And this is very intentionally being designed from the demand or from the industry perspective. But then, as you can see, in the middle of the year, there'll be a market sounding, a request for market pricing to actually design and build the Australian Agri-Food Data Exchange. And there is a recognition that this is not something from first principles. Applications and solutions do exist already that can support what we need to do here. And really, this whole process is designed to inform the design of what the market actually wants and needs, and then that can go out to the technology community for them to respond to inform the actual pricing and approach that needs to be taken for that, which then ultimately heads into the business case deliverable in September, and will then need to go for a funding ask amongst various potential organisations. So just to wrap up, before we move into the breakout rooms, first and foremost, thank you very, very much for everybody on the call today attending today's meeting. I think we had in excess of 400 people at various points. But a big thank you goes out to the 4 technology partner groups that have participated and worked with us over the last 3 or 4 months to deliver these experiments, that being Eratos, Resair, Axis Tech, and also Telstra and IBM. And a big thank you also to the working groups that they have been collaborating with. And as you've seen, those working groups consist of a significant number of participants in the agri-food sector. It really has been quite a remarkable collaboration, and will continue to be so between now and September. Tomorrow, the organisations that are participating in the initiative are congregating for what we're calling the design workshops, and this is their opportunity to help further inform the design of the Australian Agri-Food Data Exchange and the associated business case. And there's 4 or 5 key areas that have been covered off in that: the data governance, the operating model, the benefits and the benefits realisation, the customer experience, and also the risks and the risk mitigations. And that's tomorrow afternoon. And then, as I mentioned, mid this year, there will be an open market request to the technology community for pricing inputs to the business case. If you're interested in this, please do register your interest at www.ozagdx.com.au. And the final point I'd like to make is the door remains open to additional organisations from the agri-food sector to come on board, join this mission and support this cause. We really do have an open door, and we'd love to welcome additional participants to collaborate on this project and to help us successfully drive it forward and provide support and insight to achieve a collective outcome. So thanks again, everybody, for joining us today. We really, really do appreciate your time and your input. And I think, Andy, we are now going to hand over to or open up 4 different breakout rooms. Those breakout rooms will be using Microsoft Teams. We won't be coming back to the plenary session today. So when those discussions conclude, that will be the natural conclusion of today's proceedings. I think we've allocated about 20 minutes for each of those breakout rooms designed by technology partners and the working groups. So I think on screen, hopefully popped up, you now find links to each of the 4 breakout rooms. There's obviously a compliance and certification working group that will feature Irene and the team from Resair. The second one is the biosecurity working group with Marta and the team from Aerotos. The third one being benchmarking, that's with Chris Blanchard and the team from Axis Tech. And the fourth one, of course, is the demo we've just seen. That's led by Jojo, but in conjunction with Telstra and IBM. Of course, you will also be able to move between the teams as well. We will post the links so that you can shift between the discussions if you like. But everybody, thanks again. Really do appreciate your time today. This is a super exciting collaborative project that's really designed to help drive and genuinely digitally transform the agri-food sector in Australia. So thanks again, and we'll see you in the breakout rooms.